I see it coming through.
Mm-hmm.
XRISM is our newest X-ray telescope in space. It's a JAXA-NASA collaborative mission with ESA participation and will revolutionize X-ray observations of the universe. It does this with a one-of-a-kind sensor that captures data with 36 super-cooled pixels. Yes, you heard that right. This groundbreaking detector isn't measured in megapixels, it's a 6x6 grid of 36 pixels. But they're unlike any others. Although this detector, called Resolve, can create low-resolution X-ray images, that is not what makes it unique. Each pixel in Resolve is a microcalorimeter, so it can measure tiny amounts of heat. A 6-stage system cools it to 50 millikelvins, or a fraction of a degree above absolute zero. This extreme low temperature allows Resolve to measure how much a pixel warms when it absorbs a single X-ray, and therefore measure the energy of that one particle of light. It's basically a precise way of measuring the X-ray's color. As a result, XRISM can create the most detailed X-ray spectrum ever for distant objects. This spectrum can give a great deal of useful information, like temperature, what elements are present and in what quantities, and how fast an object is moving toward or away from us, even if we can only see it as a dot in the sky, too distant to resolve details. This would be a revolutionary achievement for a detector with a single pixel, but Resolve has 36. This allows XRISM to observe extended objects that aren't point source dots and create spectrum maps of their different regions. That can reveal speed and temperature differences in extremely hot gases. Using that information, scientists can determine how nebulae and galaxy clusters have evolved and interacted over time. The Resolve detector was invented and built at NASA's Goddard Space Flight Center. The detector's success in XRISM will enable Goddard to further the design and follow up with X-ray microcalorimeters with hundreds or even thousands of pixels. So, while it may not sound as impressive as 4K or 50 megapixels, the Resolve detector on XRISM will be revolutionizing our understanding of the large-scale, high-energy universe. And that's pretty amazing for a mere 36 pixels.
Well, hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and I'm reaching out very far, all the way to Arizona from Arkansas, to add in David Levy, who's on with us from Vail, Arizona, from his observatory and home at the Jarnac Observatory. And he's got his beautiful Questar there with his Coronado PST. I imagine that you did, was it clear enough for you to get some solar observation today, David?
Yes, indeed, I did. There were 9 groups of 72 spots and 6 prominences today. I got them with this half of Cupid just before I dropped it. And so I'm hoping it'll still be working tomorrow.
Okay, well, that's great. That's great. Well, we've got a big show. I sound like Ed Sullivan there, really big shoe. Today, we've got Don Knapp from the Astronomical League. Seth Shostak is coming to us from SETI. So if you don't know who Seth is, he is a longtime astronomer at SETI and worked with Frank Drake, who came up with the famous Drake equation and all the rest of it. Seth's presentations are often humorous, but full of information. And I think that his talk today is going to address maybe some of the congressional hearings that we've had about UFOs and UAPs and, that kind of stuff. David Eicher from Astronomy Magazine will be on with us. I have forgotten how to pronounce this catalog name, but Sacha Riasan, maybe, is it's from this catalog. And as far as I know, David, there's only one object in that catalog. I don't know if this is true or not, but and on any account, it'll be very interesting. Marchelo Souza from Brazil is to be on with us. Chuck Allen, president of the Astronomical League, will also be joining us. Robert Reeves, our resident moon expert. Dr. Daniel Barth, who hasn't been on for a long time, joins us again. So it's great to have him on. John Schwarz, also a space artist, he's going to be joining us. Adrien Bradley comes on, and then Carlos Hernandez. And so maybe not quite in that order, but that is the group today. So we've got about a dozen different presenters. And so I think we should probably get started, and we'll do that with you, David. I'm just going to turn it over to you.
Did you say me?
I said you.
Okay, thank you. Thank you so much, Scott, and welcome to our 162nd Global Star Party. I've been at all of them except one, and I really do look forward to them. I sometimes cannot stay till the end, but I do my very best I can. This theme today is precious, exploration. And the first I heard of exploration was when I was 3 weeks old, and I was informed that the Palomar Observatory, the 200-inch, was being dedicated that day when I was 3 weeks old. And I told my parents that I wanted to fly out there and give a big, long speech. And they said, David, you're only 3 weeks old. You can't give a big, long speech. And I said, sure I did. And I gave a great big, long speech in Latin and translated it into Hebrew. And everything was fine until Dave Eicher called and said he would not be publishing it in Astronomy magazine because of the Latin and the Hebrew. But anyway, here it is. The poem that I would like to recite today to celebrate the theme of exploration was written by none other than Alfred Noyes. They knew how to open a telescope back then. They hired a poet, a very famous poet, to come over, and he offered to write a poem specifically for the opening. And I think you might enjoy this. I'm going to read 2 stanzas from it. Watchers of the sky. At noon, upon the mountain's purple height, above the pine woods and the clouds, it shone, no larger than the small white dome of shell left by the fledgling wren when wings are born. By night, it joined the company of heaven, and with its constant light became a star. A needle point of light, minute, remote, it sent a subtler message through the abyss, held more significance for the seeing eye than all the darkness that would blot it out, yet could not dwarf it. Tomorrow night, so wrote their chief, we try our great new telescope, the 100-inch. Your Milton's optic tube has grown in power since Galileo, famous, blind and old, talked with him in that prison of the sky. We creep to power by inches. Europe trusts her giant 40 still. Even tonight, our own old 60 has its work to do. And now our 100-inch. I hardly dare to think what this new muzzle of ours may find. This is such a beautiful poem for the then largest telescope in the world, the 100-inch atop Mount Wilson. It beat off the Dominion Astrophysical Observatory, which was the largest telescope for a couple of months, actually a few weeks before the 100-inch was open. And before that, it was Lord Rosse's great 72-inch telescope for decades and decades to be the largest. The interesting thing is that when they did do first night light the next night, it was terrible. The images were absolutely awful. And they did whatever they could, and it was totally, they thought the telescope was a complete and abject failure. So they closed it up. And at about 3 o'clock the following morning, still dark, they opened the dome again, and they turned the telescope towards Vega. And the telescope gave the most sublime image. I think even Dave Eicher would have loved it. That first image from Vega from the 100-inch that began its long career, which is still going on, of exploration. And with that, back to you, Scotty. Thanks.
Oh, gosh. David, what do you think they would have done if the scope had really been defective? Do you think they would have
Well, they
just
would have, if
closed it
necessary,
and taken the
reground the
mirror
mirror.
out? Yeah, just
But
redo it.
this happens a lot. When I take a telescope out and it's at the end of a hot day, the first images are pretty bad enough that I want to take a stone and throw it at the telescope. But over the next hour, it's a small telescope I have, the image improves and gets better and better. The largest telescope I have now is a 12-inch from you named Eureka. And I think that telescope just works beautifully.
Thank you, David. Thank you. Well, that's great. Okay. Well, we are going to go down to Don. Where do you live, by the way?
We live in Westchester, Pennsylvania. It's about 15, 20 miles west of Philadelphia.
Westchester, and that's where QVC is, right?
Yes, it is. Yeah.
Yeah, I've had to actually appear on QVC and
really?
stuff on there before. So
yes, the other side of town from us. Yep. Sure.
Yeah. It's another universe when you go to QVC.
Oh yeah. Yeah. They often sponsor our Christmas parade.
Oh, do they? Okay.
Yeah, they have some years. Yeah. Yeah.
And Westchester is a very nice town. I enjoy going there.
It's a great town. Yeah. QVC is a big deal around here. Yeah.
I bet. Well, thank you for coming on to Global Star Party, and your talk about William Herschel is something that I'm really interested in. So, so we're going to let you take the stage.
Okay, let me share my.
Then we'll talk about the Astronomical League at the end of your presentation.
Sure. Yeah. Let me. Are you seeing my slides there? I'll start the slideshow.
Yes.
Okay. Well, thanks for having me on. When I saw the theme of exploration, it there's different ways to think about exploration, but I immediately jumped to historical. I'm certainly not an expert in history of astronomy, but I find it very interesting to see how a lot of the ideas that we take for granted today, how they developed. But before I get into that, I have to mention that we are getting ready for next summer. Instead of being Alcon, it's Astrocon in Bryce Canyon. So I would encourage anybody who wants to go, get your room reserved now. About 1/3 of the rooms are already taken. And it should be a wonderful event. So go ahead and get signed up. I'm already signed up. My wife and I are going, and several friends from our local club. So go ahead and get signed up. It should be amazing. And we have Astronomical League Live coming up. The 6th, when that would be? That would be next Friday, I think, right? Yeah. So Scott Harrington will be on. We tried to have him on once before. There were terrible storms where he lived. He was trying to connect by using his phone as a hotspot, and it just didn't work. So he will be on December 6th, 7 p.m. Eastern Time. So I think of exploration. I think of who are the explorers that I most admire. And immediately when I saw the theme, William Herschel popped into my mind. So I want to talk about him briefly. Only a couple of his discoveries. I mean, we could spend this entire show and 3 or 4 other shows to talk about everything that William Herschel did, but we'll keep it short tonight. So he was, I've always thought of him as William Herschel, but in fact, he was born Frederick Wilhelm Herschel in Hanover, Germany. And he was a very respected and accomplished musician. Then he relocated, went to England, and from then on, he was known as William Herschel. So this is the book. I believe that when he was the age of 35, he got a copy of it. All the references I've looked at call the book Astronomy. This must be the book. It's the only book by Ferguson that has astronomy in the title in this way. So this is the kind of book that I would like. It's if you read it, it says principles made easy to those who have not studied mathematics. Sounds like one that I would enjoy. So at 35, he really started looking at the stars. And he, at the time, of course, Newton invented his Newtonian telescope about 100 years before. But those telescopes, I think Newton's first scope was only about a little over an inch mirror in diameter, 1.3 inches. And even during that time, 3 inches was considered about, the average or all that would build. So Herschel said, this is not enough for me. So he started building telescope mirrors. This is a replica. I think this is, I couldn't identify, but I think it's the 6-inch. And something I want to point out, if you look up here, there is an eyepiece up here, which means there must be a diagonal mirror. If you can see, he's got a whole system of pulleys and rope and a crank handle to adjust the right ascension, well, the elevation of the azimuth and the altitude of the scope. In later telescopes, he eliminated the secondary mirror because they didn't reflect well. They used a metal called speculum, which is a tin and copper alloy, had to be polished routinely. So he eliminated the mirror, the secondary mirror, and I suppose he must have eliminated the eyepieces. I really would love to know more about these telescopes he built. It became what they call an off-axis design, where the mirror, instead of being reflecting directly up the barrel, it reflected a little bit to the side. So I think in this bigger telescope, he just looked down the barrel. So I'm hoping someone can maybe enlighten me on that. But here's his polisher. This is a replica on the left-hand side. This was his actual mirror polisher on the right. It's on display in the Science Museum of London. Over the years, he built up to 400 mirrors for telescopes. He sold 60 of them, one of which he sold to the King of Spain for what now would be the equivalent of well over $1 million. So he was a really accomplished producer of telescopes. I have one quote here. I'll have to read this because, as we'll talk about a little bit later, he worked very closely with his sister Caroline. So these are Caroline's words that happened when they were pouring the mirror out of metal for the 30-foot length telescope, focal length telescope. So she says, a day was set apart for casting, and the metal was in the furnace, but unfortunately it began to leak at the moment when ready for pouring. And both my brother and the caster and his men were obliged to run out at opposite doors, for the stone flooring flew about in all directions, as high as the ceiling. It says, my brother fell exhausted with heat and exhaustion on a heap of brickbats. So it was high adventure back then. This is the scope that he is probably most famous for. This is the 40-foot focal length telescope. He appealed to King George to cover the cost of this. Without support from the king, he could never have been able to build it. It was a massive undertaking. It's a 49.5-inch primary mirror at the bottom. You can see the entire assembly is mounted on wheels that turn. Tends your mind a little bit of the way telescope domes move today. You can see his ladders to get up to the platform. This is a viewing platform. And from what I can tell, all he did was look down. It would be focused so that the image would be at the edge, so his head didn't block. He didn't want to block the incoming light. This was the largest scientific instrument that had ever been built at this time. This was in 1785. And again, a triumph of human perseverance and zeal for the subliminous science. So the 40-foot was the world's largest telescope for 50 years. And then Lord Rosse built his 72-inch Leviathan at Parsonstown in 1845, and that is pictured below. But the 40, you can imagine having to climb up and down, have a crew. You can see there are gears and handles over here that would turn the telescope and lift it up and down. A lot of block and tackle here. It was hard to use. He really didn't use that often. Instead, he stuck with a 19-inch reflector. He used that to discover most of the nebula. And nebula, I'm using that term, that's a term that they used back then. And that really, at that time, was everything except stars. You know, as we know now, some of the fuzzy spots we see in the night sky in our telescopes are galaxies outside of our galaxy. But we didn't know that until Edwin Hubble, Harlow Shapley discovered that with the help of the 100-inch telescope at Mount Wilson. At the time, they thought all these things, all these nebula, were in our galaxy. So probably what he is most known for is Uranus. So this was very early in his career. He observed what he thought to be a comet, but found out it was the planet Uranus. And with this discovery, he was elected to the Royal Society, and he could stop worrying about his music career because now King George III gave him an annual grant. And of course, then later, the king paid for building telescopes. So he gave up his career in music, concentrated on astronomy. Uranus was the first planet discovered in modern times. He did a lot of searching through the skies, and he found this with just a 6-inch Newtonian, which I think is the reproduction I showed earlier. Again, this Uranus had been seen many times, but everyone thought it was a star. Herschel named it Georgium Sidus, which means the Georgian planet, because he named it after the guy was paying for his work. It makes sense, right? But the other astronomer, they called it Herschel. Uranus really just was proposed by Bode, and it matched the historical naming of planets from classical mythology. But it really wasn't accepted in common use until 1850 or so. Now you can do your own exploration of Uranus. Okay, here's a sky map. Uranus reached opposition mid-November, so that means it was opposite the sun. So it's in prime viewing time in the evening. You can really see it all night long. Not hard to find at all. I could go out tonight, well, maybe a little later than this, maybe 9 o'clock or so. Orion will be rising in the east. I just go up through the Hyades to the Pleiades, and then off to the right will be Uranus. Now, if you have binoculars, you can probably just scan, because Uranus will be a distinct greenish blue color. But if you're using a telescope, you want to do what we call star hop. So you would focus your telescope on the Pleiades, put them in the left-hand view, and focus and mark some stars with your eye. Just take note of the stars in the right hand, and do that across. Hop from one star to the next until you get to Uranus. It will be readily seen as a disk, especially in a telescope. It's a beautiful blue-green color. So I would encourage you to go out and look. Now, Herschel did many other things before I get into the Milky Way. But after Uranus, he started observing deeper into the sky. So not long after he discovered Uranus, the only object in the sky he had seen was the Orion Nebula and his companion M43. He had seen M13 and Hercules, the globular cluster, and of course Andromeda Galaxy. But in 1782, he started a very systematic and extensive search. By 1786, he had documented 1,000 objects. By 1789, another 1,000. And over the course of 20 years, he had documented, cataloged 2,500 different objects in the sky. He studied the Milky Way, but some of the funny ideas that came out that I discovered, he was sure he had ample evidence of life on the moon, and he compared it to the English countryside. He theorized about other planets. He had an idea that Mars was where there was life, just like we have on Earth. I mean, this idea went on for a while. I remember when I was in grade school in the 50s, seeing pictures in the books of what people speculated was jungles on Venus. So it wasn't really until the modern time we know how difficult it would be to have life on these planets. But he did study this Milky Way. This is his picture of the Milky Way, his model of it, based on what he saw and measured. He did get the shape of a disk of the Milky Way, but incorrectly assumed the sun was in the center of the disk. So other than Uranus, another one of my favorite objects that Herschel discovered is the Garnet star. This is an incredibly beautiful star. It Mu Cephei is its formal name. It's a red supergiant, and it's one of the most luminous red supergiants in our galaxy. It's one of the largest and brightest stars visible in the entire Milky Way. Now, it doesn't appear that bright to us. Okay, when I say brightest stars, it's the actual brightness, not the observed brightness. So again, it's not a very bright star for us, around 4th magnitude, but our telescopes have shown that it is one of the largest stars. In fact, it's so large that professional telescopes actually see the disk of the star, which is very unusual for a star. Herschel described it when he saw the deep red color. He described it as a very fine, deep garnet color, such as the periodical star SETI. So the formal name of the star is Arrakis, okay, but is more commonly known as Herschel's Garnet star. And that's what I call it. And I love to share the view of that during star parties during the colder months. When I first heard the word Arrakis, I immediately thought of Dune. I have the novel actually behind me, up on my bookshelf. But the star in the planet in Dune was named with an A, Arrakis, but it certainly reminded me of Dune. So you can explore Herschel's Garnet star for yourself. Okay, it's not easy. It's easy to find. If you go out tonight, you can find Cassiopeia, easy to find, the W in the sky. Ursa Minor, of course, the North Star, and in the middle is Cepheus. Okay, it's only 4th magnitude, so it's a little hard to see naked eye. In fact, I'm not sure I can see it at all from where I live here, too close to Philadelphia. But binoculars will help, and you can zoom in on it. So Cepheus is a house. Here's the roof of the house, and you can find the Garnet star in the foundation underneath the floor of the main house. So I would encourage you to go out. Binoculars are good, telescopes even better. Now, it's hard to talk about William Herschel without talking about his sister Caroline. She spent a lot of hours polishing mirrors. At night, when William was observing, he would usually, I think it was with the 20-inch, the 20-foot long telescope he's used, he would have to observe, come back inside where he had light, write things down, go back out, wait for his eyes to adapt. That got old fast. So he had the telescope set up near a window, and Caroline would sit inside the window, and he would call out his observations, and she would write them down. So it sped up the observations very, very quickly. So she was with him for many years, polishing mirrors, and she was an observer of her own, in fact. Caroline made her own discovery. She discovered 8 comets after William built her own reflector telescope. She could sweep the night sky. She discovered 8 comets, 14 new nebula, as they call them, 14 new deep sky objects. When he went, William was called to Windsor's Castle to the king, and when he presented the comet to the royal family, he called it "my sister's comet." So he really took great care of his sister. That is until he got married. Once William got married, the things were never the same again. Caroline was very jealous of her brother's wife, and so things weren't as happy from then on. But she continued to serve, taking notes while he observed. She was actually given a salary by King George, and she really was one of the foremost science females in England, or if not the world. The first female in England to be honored with a government position, and the first woman to be given a salary as an astronomer. So she was a groundbreaking woman in England. The last object I'm going to talk about is going to be double stars. When William observed stars, he did an extensive observing of double stars By the time he was finished, he had cataloged 800 double stars. So I guess everyone has favorite constellations. Mine is Leo the lion. Why? Because Leo the cat was a wonderful cat we had with us for 12 years. But when I see Leo in the morning, in the spring evenings, when I see Leo coming up late at night, I know that spring's not far away and the warm observing months are coming. But I really like to see Leo. And there's a star that is beautiful, a double star. It doesn't quite compare to the double or to Alberio or the Mizar and the Handle, but is this one here, Algeba. Okay, it's the second magnitude. So it's fairly bright, but it's in Leo the Lion at his main. So Herschel did a lot of work on double stars, and at the time, astronomers expected that changes in the apparent separation and the location could tell us where the proper motion was and how far away they were by parallax. Now, parallax was a method suggested by Galileo. You can demonstrate that yourself if you hold your finger out at length in front of you, close one eye and see what's behind it, then close the other eye, shift eyes, and the way that the background shifts against your finger, that's the way they were measuring the distance of stars. They would do it in one season and then half a year later, when they're on the other side of the sun, measure it again. So that was developed by Galileo Galilei, and William Herschel did a lot of double star investigations. He determined that they were gravitationally bound. And in the television series Cosmos, Neil deGrasse Tyson talks about this discovery. And by carefully observing Algeba, Herschel was the first one to make the assertion that gravity that binds us to the Earth also reacts with stars. What keeps double stars together is gravity. He was the first scientist to make that assertion. So if you ever want to see or hear and see William Herschel brought to life, watch Oz Cosmos of Space Time. It's in the 4th episode, and Patrick Stewart, better known as Jean-Luc Picard of Star Trek, he gives the voice to William Herschel, and he does a wonderful job of bringing William Herschel to life. I've watched that part of the show probably 5 times, and I'll watch it again. It is just wonderful to hear Patrick Stewart bringing William Herschel to life. And in the episode, his son John is with him, so John Herschel is also there in the episode. The Astronomical League does honor William Herschel. There is a program called the Herschel 400. A lot of us and a lot of people who are listening have done the Messier catalog, seen all 110 of those objects. But for anything beyond that, there was nothing that existed. Where do you go next? Well, the Astronomy Club down in Florida came up with this Herschel 400 observing program. And it is challenging. I am not working on it. It's a bit beyond me, but there are many people that do it and observe it. Is an advanced program. Beyond that, there's the Herschel 2, 400 more. Okay, so that would be 800 of the 2,500 deep sky objects that Herschel cataloged. So again, it's an advanced program of the 400 objects of over 300 galaxies. So you need to have a pretty good sized telescope for this. They're between magnitude 11, 13. So I would think a 12-inch Dobsonian or 12-inch reflector of some sort would be what you need to do this program. But yeah, the Astronomical League does honor Herschel's contributions to the world of astronomy. So I found this sculpture when I was researching for this talk. This is a William Caroline, and it's called the Stargazers. It sits in a garden wall near the entrance of the William Herschel Museum in England. It was actually unveiled in 1980 by Sir Patrick Moore and Rod Davies, both very famous astronomers. If you take a look, you can see Caroline here in her bonnet, William over top, looking up to the stars, Caroline with a quill pen, taking notes, and there's a small drawing of the solar system here on her piece of paper. It's a beautiful, beautiful sculpture. So as the most renowned astronomer, I would say, of his time and of all, he's one of the most renowned astronomers of all time. He contributed to many things. He discovered that the ice caps of Mars vary seasonally. He detected the way Mars spins. He modeled the Milky Way, as we saw, and he even talked about the possibility of galaxies beyond our own, external island universes. So he's way ahead of his time. And he discovered infrared light. So on his tombstone, he has an epitaph. I will ask David Levy to do the correct pronunciation, but I will read the translation. He broke through the barriers of the heavens. He was an amazing man. So thank you for listening. These are my sources of information. I spent a lot of time reading for this presentation. So, and I will close my window here. Maybe Scott, you can do that. I lost the window somewhere.
I can do that. Let's see.
There it is. Okay, I found my window again. There it is.
Here we go. Great.
You got it?
I got it. Okay, that's wonderful.
Yeah, I lost my window for a moment there.
Yeah, I keep on my desk a little Herschel telescope here.
Oh, that looks just like the one I showed the replica of. Yeah.
That's right. The 6-inch. I think it's an F14, something like that. Yeah, there's a guy named I think Christoph or something like that. He made these miniature models of telescopes.
That's beautiful.
Yeah, it's really cool. So.
Yeah, it's the same one that I showed the picture of. Yeah.
Yeah. So, doesn't have any go-to electronics though. So if that's what you're looking for, Herschel did astronomy the organic way. That's for sure.
He was a true explorer. He really was.
That's right. Don, thank you so much for participating, and we want to extend thanks again to the Astronomical League for being with us on all of these global star parties, and I'm looking forward to the AstroCon conference that you guys are doing in Bryce Canyon, and I think you've already covered some of that stuff, but if you guys have not, if you're watching the show right now, you have not joined the Astronomical League, you should do so. You could do so by joining a club that is a league club, and there's plenty of them. There's over 300 in the world, and or you can become a member at large, and it costs a little bit more, but well worth it. These guys have over 80 observing programs. They have dozens of awards to recognize people for various achievements that they do in astronomy. And if you attend one of their the Alcon events, or AstroCons, they're sometimes called, you're going to meet some really nice people, and you're going to make some new friends. So thanks very much, Don. Thanks you.
Thanks, Scott. Thanks for having me.
Okay.
My thanks as well. You obviously did your homework on this.
I did.
It's a fascinating presentation. If you don't mind, I'd like to pass on a little story that happened with me years ago when I was visiting London to give a lecture in England. The host who was taking me, we decided to stop at the William Herschel Museum, which was at the home where he did a lot of his work. And so we stopped, we rang the doorbell, and they came to the person in charge opened the door, and he said, I want to say that today we're closed and I'm not going to be able to let anyone in for a tour. And the person taking me on the tour said, well, this is David Levy, he's giving a lecture tonight. I was just wondering if we could take a quick look. And the director said, well, I'm very sorry. So we went back to the tour car, and we were just sort of sitting there trying to plan the rest of our trip for that day. And just as we were about to leave, the director opened the door, came rushing out to our car and said, the museum is now open. Please let me show you around. And when I walked in, he said, I looked you up on Wikipedia and changed my mind. And he showed us the spot in the backyard where the planet Uranus was discovered. And that was such a
Wow.
thrill I'll never forget.
Wow.
Anyway, good lecture and thanks, Don.
You're welcome.
Great. Okay. All right. Our next speaker is Seth Shostak. If you've never seen Seth Shostak speak before, I think you're going to be in for a treat. He is the senior astronomer at the SETI Institute and a leading voice for the search for extraterrestrial intelligence. I don't think he's actually the voice for extraterrestrials just yet, but anyhow, known for his engaging public outreach and scientific expertise, Shostak explores the possibilities of alien life while advancing SETI's mission to detect signals from advanced civilizations. He's a great guy. If you ever get a chance to meet him, very approachable, and we're really happy to have him on Global Star Party once again. So thank you, Seth. And let me bring you on. Here we go. And you are muted.
How's that? Is that any better?
That's better.
Okay. To be honest, my remarks will probably be better if they are muted. Anyhow, I'd like to thank Scott for giving me the opportunity to spend the next 3.5 hours speaking to you about the effects of inverse Compton scattering on the forbidden yttrium lines in the atmospheres of peculiar A-type stars. That was the topic that he gave me. He said would appeal most of all to the attendees of this Global Star Party.
That's right. That's right.
Actually, I'm going to talk rather briefly because I don't know, I don't recall anybody ever asking questions here, but I always appreciate when people do ask questions if I'm giving a talk, because I assume those are things they're really interested in as opposed to everything that I've said previous to their question. So the nominal topic of these low-grade remarks is what happens if we actually pick up a signal? As you know, SETI has been an endeavor since 1960, actually. That's a long time now. That's 6 decades. Trying to, Frank Drake did an initial listening experiment back in 1960 in Greenbank, West Virginia, trying to pick up the aliens on the radio. And that would not only prove that the aliens are out there, but it might conceivably put us in touch with the aliens. And that's something that everybody would like to do because, you know, everybody's a graduate of not Star Wars, but Star Trek, where we actually interact with the aliens and not as their victims. Anyhow, let me just say a few things about what you can expect, because this is what I think may happen in the next 20 years. To begin with, I think we're going to pick up a signal. I've said that here before, and you know, you can dismiss that immediately as simply wishful thinking, and maybe it is, but it's simply based on the fact that our SETI experiments are much better than they used to be, and we're going through nearby star systems at a pretty rapid clip, and the speed at which we're scrutinizing the nearby cosmos is actually improving. It's increasing. So that clip continues to get clippier. If we do pick up a signal, of course, the next question everybody will ask is, well, what are they saying? And they might not be saying anything. It might just be a signal, all right? Just a carrier wave, just the kind of squeal you might get on your radio set if you're just tuning between stations and you pick up a squeal. You don't know what the programming on that station may be, but you know there's at least a transmitter somewhere. So that might be the first thing that happens. But as Philip Morrison, a fairly celebrated physicist at MIT, said years ago, to me actually, but there were other people in the room, so he was less hesitant. He said, look, the aliens aren't going to, just transmit an empty signal. Of course, there will be a message with the signal. There will be modulation on the signal. In other words, the signal will change in some way, right? Maybe it'll be pulse code modulation. Maybe they'll just, frequency modulation. They'll switch between a couple of tones the way it was done down in Arecibo when they sent that message to a nearby globular star cluster. Actually, I don't think any star clusters are that nearby, but in any case. Okay, so there will be presumably a signal. And, the next step would be to, well, can we decode that signal? Can we figure out the encoding? Are they sending us words? Are they sending us pictures? Are they sending us, dry mathematics? What are they doing? And we might be able to do that. I mean, you'd have, a lot of people around the world working on decoding that alien transmission. I mean, nothing would guarantee their fame quicker than to be the first one to understand what the aliens are trying to say to us. So I think that we might decode the modulation. And maybe the questions are simply, somewhat inane. They're just telling us who they are and where they are and, and what they do for a living or, what their annual income is. I don't know what it might be, but the message might be fairly trivial, but I don't expect so. I think that if they're going to send a message to potential receivers light years away, right, then they're not going to make it a trivial conversation or a monologue, because conversation will be quite hard, right? If they're 20 light years away and they send us a message, we pick it up and we decide to respond. It takes another 20 years for our response to get to them. And if they find that interesting enough to respond to that, another 20 years goes by and so forth. So there would be a temptation, it seems to me, and to many people, that they would send a lot of stuff the first time, right? I mean, if you can imagine putting a note in a bottle, right, in Europe and sending it on some current that will reach the Americas as their first communication with the Americas, right? They probably wouldn't just say, hi, we're the Europeans, and let it go at that. They might put a particularly good book in there or something. So I think that they would, if they're going to transmit anything to us, it's likely to be something that has high information content. And of course, you can hope that it will. The immediate question, of course, that will arise here on Earth is, well, shall we talk back? And there are mixed views on that. A lot of people think we should talk back. I among them, not that that matters much, but there are going to be plenty of people who think talking back is maybe not a good idea because you don't know what these guys are like. I mean, they might be friendly, they might be interested in educating us in all of physics or whatever. But on the other hand, they might only be interested in, I don't know, coming to Earth and taking our natural resources or, just killing everybody for the fun of it, or who knows. So they would argue against communication because you don't know anything about the beings that you are communicating with. All right, let's consider a little bit about the question of could we understand a message. Now, I'm going to assume here that the message comes in either as a radio signal, because that's what SETI usually does. We try and pick up radio transmissions, but it could also be flashing laser and so forth. So all those are possible, but it's going to consist of the signal itself, the carrier, if you will, just the squeal that tells you that they're on the air, and then the modulation, which is to say the information that's on top of that signal. And we would have to understand it, we would have to figure out that modulation scheme, right? Are they sending us AM modulated radio waves? Are they sending us FM modulated? We need to know, how they've encoded it, that kind of thing. And of course, all those things are kind of technical things, but they would be essential for us to figure out if we're going to understand what they're saying. And of course, then you're still left with the fact, okay, now I've got the modulation, but what the heck does this mean, Bob? I mean, I don't know, right? So that would be an endeavor that might take many, many years. And my personal opinion on that is that you should just make the signal available, just put it on the web, make it available to the general public and let them try and figure it out. Because it turns out that contrary to your daily experience, the general public is actually fairly clever, and they might, in fact, figure some of this out. Okay, then there are sociological aspects to the whole matter of communicating with the aliens, because presumably, if you can figure out what they're saying, you might want to reply to it, right? They might be asking you questions. They might be telling you something that's useful to you and expecting to hear a reply from you simply because they want to know whether you've got the signal, for example. And so there is this potential danger there. You'd have to make some assessment of how dangerous it is. Now, obviously, if the aliens that are getting in touch with you are 30 light years away, I don't think you have to worry too much about the danger. They're not going to come here. They're a long way off. They're not going to threaten your lifestyle, okay? But there's also the possibility of trade. That's something that's typified exploration, which is, I think, the theme of this particular get-together. Exploration provided an opportunity for trade, and that was one of the great and important consequences of exploration. Well, maybe the same thing would be true here. Maybe we could trade. That's occurred occasionally in movies. In movies, you know, they trade. I don't know what it was in. I'm trying to think of the film where they had something that they found worthy of exchanging with some other society. Maybe that'll happen. That doesn't happen terribly much in science fiction, I have to say, at least not in the movies or in television shows about it. Usually the two sides are at such disparate stages of technical development that trade doesn't really make sense. It's like having you trade with the squirrels in your backyard. I mean, you could try and initiate that, but it turns out the squirrels have rather little interest in it. And beyond that, there's not much they can give you other than acorns. So I don't know about trade. Maybe. There's also the entertainment. Maybe, you know, what they're sending is their top 40, or maybe they're you know, the TV shows that play well with the aliens. Maybe you would find that interesting. At some level, it'd be interesting. I'm not sure it'd be very entertaining. The last thing they might be trying to do, that I've written down here at least, is they might try and educate you. They might try and teach you something. And that's a very, you know, common theme in any discussion of this possibility for interaction with other societies. Maybe they would teach us how to, I don't know, whatever. They teach us all of physics, or they would teach us all of astronomy, or they would teach us how to cure death or disease or whatever. Maybe they do that. I mean, that usually assumes that they're altruistic. There are papers out there about whether the aliens might be altruistic. It's not been our experience terribly often here on Earth that people who find another society are altruistic. I mean, the Europeans came to the Americas, and it wasn't that they were really trying to educate the natives here. They didn't do too much about that, but you know, they found things to trade with them, so there was that. Okay, all that being said, I really want to open this up to any questions people have, because I'm sure you have more interesting aspects to discuss here than I do. But I think that this is not just a theoretical problem, as I've said on these fora before. I do think that within the next couple of decades, we will pick up a signal, and there'll be tremendous pressure to send communication back in the direction from which the signal came. And consequently, it's quite conceivable that at some point we'll be talking about communication between societies. Now, any society we pick up, this is something that the movies get wrong, any society that we pick up is going to be more advanced than our own. That's not, you know, not the way you see it on television. Star Trek, I mean, you know, you can converse with these guys in colloquial English, as seems to be the universal language of the Milky Way. You can do that, but they're always more or less at our level of sophistication. And that isn't likely to be the case, because obviously the ones that are not as advanced as we are, you're not going to hear from those guys. And the ones that you do hear from are more likely to be maybe millions or billions of years more advanced, because the universe has been around for a long time. And the chances that they're, you know, within 100 years of your own development are quite small. So you're going to be suddenly in communication with a society that might be 1 million years more advanced. And the question is, what can you learn from those guys, if anything, if you can even understand what they're saying?
Yep. There is a question here. John Ray is watching on Facebook, and he says, Seth, how did you process Stephen Hawking's stance on communicating with ET? He says, I believe he was excited by the idea, but fearful of the possible consequences.
Yeah, Hawking made the point that every time, at least in human history here, every time a less advanced civilization comes in contact with a more advanced civilization, it usually doesn't work out terribly well for the less advanced civilization. And the obvious example was, you know, the inhabitants of North America in the 15th century getting in contact with the Europeans. The Europeans were more advanced, not terribly more advanced. It's been estimated that they were maybe 200 years more advanced, but that was enough to give the Europeans the upper hand. Whatever the Europeans wanted to do in the Americas, they could pretty well do. And so it didn't work out so well for the natives. And what he's saying is that that could also obtain here, that in fact, we get in touch with these guys and they decide, well, they're only interested in us for, the molybdenum or whatever it is that's on our planet. And consequently, we're not going to get a whole lot out of that relationship, even assuming that they don't simply destroy us because, it's just something for the kids to do on the weekend, the alien kids. So it may be that indeed there's some danger here. And that has, in fact, played a role in at least one aspect of the whole SETI endeavor, and that is the people who are not content to merely listen for signals, but who want to broadcast signals to try and encourage the aliens to get in touch. And there have been, several experiments in which people have picked out a nearby star system, trained a big antenna with a radar transmitter on it, and, keyed the radar transmitter to send some message, usually a picture of some sort, to that star system in the hope that they might wake the aliens up. Now, that we've never heard back from any of these aliens, but on the other hand, it has to be said that most of these societies, or at least these putative societies, were tens of light years away. So maybe it's not so surprising we haven't heard anything yet. Maybe we'll never hear anything. Yeah, did that answer that question?
I think so. Recently we've had congressional hearings about UAP sightings, testimony about crashes and crash recovery, this kind of thing. And I was curious. I mean, we haven't talked to these guys, through any of the equipment that you guys have. And there's a question about telescopes that SETI uses for their research. But is this complete hogwash in your mind? I mean, I'm very skeptical myself. Okay, but I've long been a UAP, as we used to call them, UFO skeptic, and I guess until I shake hands with an alien, I'm going to remain a skeptic. So.
Well, Scott, I'll send some
You have
aliens
all
over.
these experts, so-called experts or admirals or whatever, that are testifying that, hey, this is real.
Well, it's not that they testify so much as that they hold hearings, right? And there have been surveys, more than one, in which the public is asked, well, do you think that the aliens are out there? Well, the majority of the public believes the aliens are out there, and probably the majority of you believe the aliens are out there. But the next question is, how many of you think that they've come to Earth? And it's usually 60 or 70% of the respondents who think that they've come to Earth. And for what purpose, they're a little less clear on. But, obviously, I don't believe that. I mean, I think if they'd come to Earth, we wouldn't be talking about it because everybody would know about it. There would be lots of TV shows showing the aliens walking around Central Park or wherever they're going to go, right? I think that if the aliens had come here, you would know it. Their response to that, of course, is predictable. They say, oh, yeah, but the government's going to cover it up. And that's a frequent explanation for many aspects of this particular subject. The government's going to cover it up. Now, as I've said on these panels before, I've worked for the federal government. I grew up in the DC area, and I had summer jobs working for the government. I even had top secret clearance, right? Didn't have anything to do with aliens, but the project I was working on was something that we wanted to keep secret from the Russians. But in any case, I had top secret clearance, and I would have been really keen to know if, the government knew about aliens and was keeping that quiet. Having worked for the government, it was dead obvious to me that the government couldn't keep something like that quiet, right? But even if you don't believe that, I mean, they just didn't have it in them. They had no way to keep it quiet. But even if you doubt that, right, then you have to assume, well, the aliens are only going to make themselves noticed by the American federal government. They're not going to make themselves noticed by, I don't know, the the Belgians or the Botswanans or the Eastern Europeans or anything like that. Only Americans are favored with this information about the aliens, and that's kind of hard to believe. Anybody who works in science knows that that's not the way it happens. So I don't think that we know about the aliens. I don't think the government's covering it up, and beyond that, I don't think the government would cover it up or could cover it up. Yes.
So one of the things that you brought up earlier in our email conversations was the consequences of if we do find an ET signal, what will be the consequences, or has that been thought out, or our response to all of this? Are we going to be tight-lipped? Are we going to cower down? Or are we going to immediately respond?
Yeah. Well, no, I don't think we're going to be tight-lipped, because you couldn't be, right? If you were to pick up at a signal tomorrow at your local neighborhood radio telescope that you could prove is coming actually from the sky, and there's information on it, right? So you picked up a signal that has a message, even if you don't know what the message is. The first thing you're going to do is call up somebody at another radio telescope or optical telescope, depending on the nature of the signal, and you're going to say, look, here's the right ascension and declination where I'm picking up a signal, and here's the frequency. Would you mind taking a listen or a look as well? And so, within a week, this information is all around the world, and many people are going to be looking at it. So there's no way to keep it secret. And again, I don't see any reason to keep it secret. I mean, you can argue on the basis of maybe security concerns that you should keep it secret, but that doesn't make any sense. The aliens don't know that you picked up their signal. They're going to not launch a fleet of, rocket ships toward Earth and just flatten our planet because you picked up their signal. They don't know that you've done that. So all those sorts of concerns are a small consequence to my mind.
Right. Okay. All right. So, all right, let's see if there's any other questions here. Let's talk a little bit about the equipment that SETI does use. I think that you have been involved in the evolution of ever better radio dishes and channel, how many channels you can process simultaneously, et cetera. What did it start out with? I guess it just starts out with Frank Drake using a simple, maybe single channel. And what is SETI like today?
Yeah, well, actually, I'm not that involved with the development of the equipment, but I can tell you what I know. And it's true that in 1960, when Frank Drake did Project Ozma, the first modern SETI experiment, he had a receiver. It was basically a commercial shortwave receiver. That's all it was. But he had it connected up to one of the antennas in Greenbank, West Virginia, and it only listened to one frequency at a time, right? So it was one channel, right? And you had to hope that the aliens were broadcasting on that frequency, or you would miss their call. Now, Frank rigged up a little bit of a motor with a rubber band or something like it on a shaft that went around the tuning knob of this receiver, so he could sweep up and down the dial with this jury-rigged system, and he did so. And while he didn't hear anything that was clearly extraterrestrial, he was well aware of the problem that you don't know where to search for the signal. You don't know where in frequency to search for the signal. But that quickly led to the development of what are called multi-channel receivers. Spectrometers are really called these days. And, today's SETI experiments will listen to millions, even billions of channels, and do so mostly simultaneously. In other words, you don't have to sweep up and down the dial. You can listen to essentially all reasonable frequencies simultaneously. So, this is a good deal. I think that maybe the only reason, it's a good question that I get asked. You've got all this sophisticated equipment. You're listening to millions of frequencies, but you still haven't heard ET. Why is that? Well, we don't know why that is, but a few possibilities. One, maybe we still haven't listened to the right frequency. That's possible. Second possibility, you're tuning to the right frequency in there somewhere, but you don't have enough sensitivity. The signal is much weaker than what you can find. that's certainly a possibility. I mean, you don't know what the power level of the alien transmitters are. And the third possibility, of course, is that there are no aliens out there. But I don't think anybody on this particular call would believe that.
Mm-hmm. Mm-hmm. Well, what about if it is true that we have UAPs or UFOs flying around in our atmosphere, wouldn't we pick up some sort of transmission from these guys flying around?
Well, maybe you would. I mean, it depends on whether they had transmitters at frequencies and power levels that you could pick up. But I think that if you had UAPs flying around the atmosphere, and that's where they most like to fly around, if they were flying around, as opposed to flying around the downtown bars of Mountain View, California, if they're really flying around the atmosphere, yeah, I don't know that you'd pick up their signals, but you would at least see them, right? You could see them. I mean, maybe you can't see them with your eyes, maybe you don't see them with your 6-inch reflector, but they're going to be visible to other things that are scrutinizing the sky. There are plenty of military telescopes, I don't know if I should call them telescopes, but instruments that are scrutinizing the sky. And as I think I said last time, there's something like 8,000 satellites in orbit around the Earth that are sending signals back down to the Earth. Most of these are, reconnaissance satellites or military satellites. I mean, they have a multitude of uses. But in any case, they're sending these signals back down. And, so we're fairly well aware of what's in orbit around the Earth. And if there was an alien spacecraft that was making any sort of noise, I think that we would have little difficulty in finding it.
Okay, all right. Yeah, I want to apologize to the audience. I've got some sort of buzzing or something like that going on with my microphone. I think it's probably aliens trying to get through. So.
Well, that's the usual excuse, yes.
Okay. There was also a question about the SETI at Home project. I remember when it came out, a lot of people had SETI at home churning away, on their computers at home, and that was contributing to the greater good as kind of a citizen science project. Is that still going on, or?
I don't think it is, actually, Scott. That was an initiative of the University of California at Berkeley, and those guys did it for quite a number of years, and there were 7 million people, as I recall, who actually signed up for SETI at home and were, looking for signals. They got to download some data collected by one of the big antennas in the world that was distributed by the fellows at Berkeley. But they've stopped that project, not because it was, morally offensive or anything like that, but simply because it costs money to do that. Somebody has to be charged with, managing the project, and they just didn't have the money to do that.
Understood. Well, are there any citizen science projects going on now at SETI?
Not that I know of, actually not. I hesitate to say that because, one of my colleagues may stomp into my office here and tell me that I misspoke, but I often misspeak, so maybe that's not a big deal. I don't know. Somebody like Dave Eicher might know about citizen science projects that might be relevant here. I don't know.
Jeff Swick, he said that the first signal aliens would get from us would be radio and TV broadcasts from the early days of the entertainment medium. I wonder what they would make of what they would
make of.
They would make, for instance, of what they would think of Laurel and Hardy or the dark side of humanity, such as Hitler.
Yeah, well, keep in mind, you look at Hitler and you have, sort of bad thoughts about the whole thing. But that's only because of the context in which you're watching. You know the history of the world in the 1930s and 40s. And so you know that he wasn't a good guy. But the aliens don't know that. And maybe they don't care, right? I mean, for them, it's not their problem kind of thing. So they'd only be interested in, seeing the lips on these faces flapping around and trying to determine whether they could figure out anything from that, if they could learn anything that was going on. But, the you say that the first signals that they're going to get are the ones from the 20s and 30s, the early broadcasts. That might be, but it's unlikely, frankly, because the early AM and FM transmitters, and even TV for that matter, the transmitters were not very powerful, right? And many of the frequencies that were being used for those transmissions are frequencies that would reflect off the ionosphere of Earth's atmosphere, wouldn't make it into space anyhow. So I don't think you have to worry too much about that. The signals that do make it into space, the ones that the aliens are most likely to find from Earth, are radars. I think I mentioned that last time. And the radars are not so interesting to listen to, but at least they would know that there are radars around LaGuardia Airport in New York. So maybe that would be of interest to them. Then again, maybe not.
Mm-hmm. Seth, you've been at SETI for a long time and knew Frank Drake very well. And so I'm just kind of curious, what was through your career at SETI, what was the most exciting moments for you? And, how has that shaped your view of the search for extraterrestrials?
Well, you tempt me, Scott, but I think, I don't know. I think that from a scientific point of view, the most exciting things were when we thought we had picked up a signal. And that happened more than once, right? When we pick up a signal and when, I remember when it happened, we were observing using the antennas at the National Radio Astronomy Observatory in Greenbank, West Virginia, and sitting there late at night looking at the computer screens and so forth. And this signal came through and we didn't know what it was. And it seemed to meet all the requisite, the requirements of a signal that's being deliberately transmitted from another star system. It was coming from some spot on the sky, right? It wasn't terrestrial interference, at least we didn't think so. And, that was pretty exciting because we thought, we've done it. We finally found ET. However, even though the media started calling up, by the way, which shows you that there's no secrecy in SETI. I don't know how they knew about it, but I was immediately being called by, the New York Times and stuff like that, because they already knew that we had picked up a signal and they wanted to know what the aliens were saying. Well, I don't know what the aliens were saying, but it turned out it wasn't the aliens anyhow. This was most likely interference very local to where the antenna was. So, but that was pretty exciting because we thought, well, we've done it. And I'll just report another exciting moment, not that I experienced, but that Frank Drake experienced when he did that first SETI experiment back in 1960, right? He had picked out two nearby sun-like stars to point the antenna at, and he pointed at the first antenna and he didn't pick up anything. Then he swung the antenna over to the second star system, and I think it was Tau Ceti, but in any case, he swung the antenna over to that star system, and he immediately picked up an interesting signal, one that sounded like boing, 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 and he told me that his first thought was, well, could it really be this easy? We found the aliens on the first go, kind of thing. And it turned out he hadn't found the aliens. He'd found some radar systems at a nearby airport. But, that must have been pretty exciting for a while.
Sure, kind of like the LIGO experiment. They flip it on and they get a hit. So, yeah. Adrien Nowick, watching on YouTube, wants to know if you could talk about what was the BLC-1, the Breakthrough Listen Candidate 1 from for EMA Centauri in 2020.
Yeah, I don't know what it was, and I don't think that the Breakthrough Listen guys know what it was either. I may be wrong about that, but I don't think so. They picked up a signal. Look, keep in mind, you're using a big antenna normally, right? And you've got a receiver that is listening to hundreds, maybe thousands, maybe tens of thousands of different channels, different frequencies simultaneously. So you shouldn't be too surprised that you pick up signals all the time. We couldn't turn on that equipment there that we were using in Greenbank, West Virginia, without picking up a dozen signals, right? I sat there and figured that we were picking up roughly a dozen signals every minute, okay? And we checked out as many of them as we could. After a while, you get swamped. But and they were all, the ones we were able to track down, they were all due to interference generated here on Earth. Okay, so after a while, after you do this for a couple of nights or a couple of days and nights, you become kind of hardened to the fact that you're going to pick up signals all the time, and you may not pick up ET at all. So we became a little, I don't know, I wouldn't say that we were jaded, but we were more realistic.
Sure, sure. So it may take a very, very long time before we can find any kind of signal like that. But you think that we're going to in the next 20 years. What gives you that optimism?
Well, I mean, I'm just an optimistic kind of guy, Scott, but I think that the reason is this. I mean, I bet people cups of coffee on this, but only a cup of coffee. I don't bet them $1,000 or anything like that. But it's simply looking at the rate of improvement of the receiving equipment used for SETI. And that's following Moore's law, as it turns out. So, it's doubling in capability every couple of years. And that's been going on for decades now, and will continue to go on for decades. There's no reason to think it will, slow down. And because of that, you can just calculate how long will it be before we've looked at 1 million star systems, and that's within a couple of decades. And this is just, I mean, maybe this is totally unfounded, but it seems to me that if you look at 1 million star systems, you have at least a reasonable chance of hearing ET. So that's why I think that, if we haven't heard anything by 2035 or something like that, I'll buy you a cup of coffee, Scott.
Okay, I'll be waiting. I
Seth,
think I may be buying you a cup of coffee. I hope I am. That's great.
Seth and Scott,
Yep.
can I interpose a question quickly?
You
And
sure
first of all,
can.
I have not heard, I'm not aware of any other citizen science type projects of the type you mentioned. But Seth, I wonder if, with your expertise, if you could address, there seems to be very little differentiation among a lot of astronomy enthusiasts, even the difference between the overwhelming, of course, we have evidence of life on one planet in the cosmos, but the understanding of spectroscopy, of chemistry, of the uniformity of chemistry, of the commonality of organic chemistry, of the numbers of several 100 billion stars in the Milky Way, of 100 billion or more galaxies, maybe many more in the universe. It seems overwhelming that the likelihood for civilizations would be probably abundantly throughout the universe. But that tends to be more or less equated by a lot of people to the ability to arrive, as to, land in Central Park and have dinner at 21 with us. Could you address, Seth?
I hope they're buying. Yeah.
Could you maybe mention something about the incredibly, enormously large cosmic distance scale, even between the us and the nearest stars, and the unbelievable amount of energy it would take to move things with mass, i.e., a spacecraft filled with our new friends, the aliens, from star system to star system? That seems to me to be a very, very different gamble than what seems like it might be much, much more realistic to communicate, to discover and communicate with other civilizations, although it would be a much harder quest to shake hands with them.
Yeah. No, I don't count on shaking hands with them. In particular, maybe the aliens don't have hands, but maybe you could shake a tentacle or something like that. Yeah, no, you're absolutely right, Dave. That's the case. I mean, transportation is rather difficult. Communication is not so difficult, right? If you want to actually go to a nearby star system and shake hands or whatever with the aliens, you can work out for yourself. It's just high school physics. How much energy that requires if you want to get there before you're dead, right? So, and most people do. So, yeah, that's not easy. But what is easy is to say, hello, we're the Earthlings, and we've got all these magazine subscriptions we're interested in selling you or whatever. That only requires a transmitter, depending on the size of your antenna. That could be a transmitter of 100 watts, 1,000 watts, whatever. It's something like a couple of light bulbs in your house,
Mhm.
right? So that's relatively easy.
Mhm.
Actually, meeting the aliens, I mean, you know, assuming we don't develop subspace, well, no, we don't, develop the kind of technology they have in Star Trek where you can actually, you know, get transported to another star system. I don't know how that works. I actually, I actually gave some courses a long time ago up in San Francisco about the science of Star Trek, and this was one of the tough ones. How does a transporter really work? How can you actually go from one star system to another without building a very expensive rocket? And it turns out we don't have any idea how to do that. It may be that there is no way to do that. So yeah, that may be tough, but I wouldn't worry too much about it. I mean, meeting the aliens would certainly be lovely, and in particular, if you thought you could buy them a good dinner and so forth, have a conversation with them, all that would be great. But even if that's not possible, and I kind of doubt that it is, at least being able to communicate with them might be good enough. Maybe you could have told the Europeans in 1492, forget this trip you're about to embark on, Chris. Don't do it. We're just going to put notes in bottles and communicate with them back and forth. I mean, that would be cheaper. It'd be cheaper.
Yeah.
Nobody gets seasick. So,
Much less dangerous. Yep.
much less dangerous. Yeah.
Thank you, Seth.
Thank you. All right. So thanks to our audience for all those interesting questions. Seth, thank you again for coming on to Global Star Party. And what's your next adventure? What is Seth and the company doing next at Seth?
Well, I think my next adventure is to survive Thanksgiving. But beyond that, I will, as I often do, as I always do, I'll go east during the Christmas break and deal with relatives. Not that that's particularly fun, but they expect it. They don't have any fun either, but they do expect it. So I'll be doing that.
Okay. Well, thank you so much, Seth. Thank
Okay.
you. Okay. Good night. Okay. Well, our next speaker is none other than Dave Eicher. He is the editor-in-chief of Astronomy magazine. He's a prolific author. I have several of his books. A passionate advocate for space science and amateur astronomy, and he has decades of experience. He's inspired stargazers all the way around the world, and maybe, if they're getting our radio waves out there, maybe a few space aliens are kind of interested too. But the dude's writing, his lectures, his dedication, his humor, it's a nice combination, and he's a great friend too. And Dave, thank you so much for coming on to our 162nd Global Star Party to talk about was it called the broken engagement ring? Is that right?
This is a weird one among weird objects tonight, even. Yes, indeed. And thank you, Scott, for inviting me back. Despite the fact that you know me, you're a brave humanist at heart, clearly.
Especially
It's
after that
always great
bottle
to
of
see
rum
you.
or whatever it was that they gave you at the last Sarmas.
Yeah. Now we have
Yeah.
ideas for next year at Starmus.
Yeah, there we go.
So let me share. I will attempt to share my screen. I am sharing.
Okay.
We'll share the exotic world of whatever it is. And can you see that now?
Yes. Yes.
Okay, very good. And I will see if I can start a slideshow as well, and then we'll be in business. And what I'd like to talk about tonight briefly, it's not Centaurus A, but I'll move on. And we're still in the northern sky working through everything. But there's good news, because if you're engaged recently and then you've broken it off, or your partner to be has, there's an important object in the sky just for you, the broken engagement ring.
Great.
No? I'd see a puzzled look on Scott's face here. I'm just trying to be inclusive here, okay?
I never got an engagement ring, so it's more than broken. It was non-existent.
Okay, this is the broken engagement ring. There's not a lot to say about this, even relative to some of the other objects I've talked about, because this is really just an asterism of reasonably bright stars that makes an interesting and cute shape called the broken engagement ring. It's Zacharias and 1, for the purists who want to know the catalog name there. And I will tell you that it is really easy to find. That's the upside here, because it lies just about a degree. That's a very low power telescopic field, even west of one of the bright stars in the bowl of the Big Dipper, Merak, which is Beta Ursa Majoris. That's the bottom right star as we normally see it in the bowl of the Big Dipper. So this is easy to find, the broken engagement ring, even if they're, who knows what the memories are associated with it. It contains a relatively bright semicircle of physically unrelated stars, as the asterisms are chance alignments and true star clusters are physically associated stars. In fact, the closest star cluster to us of all of physically associated stars is comprised of many of the brightest stars in the Big Dipper. So there we go. Very close to this in the sky. These stars, however, are about 7th to 11th magnitude and spread over a diameter of about 15 arc minutes of this ring-shaped splattering of stars. So it makes a really nice sight in binoculars or in low-power telescopes. And I just like to use it because it's a pretty ordinary object. There's not a lot to say about this other than it looks cute, the arrangement of stars. But it reminds us that the sky hides a lot of interesting fields of view that have nothing to do with the 10,000 or so reasonably bright deep sky objects that we can talk about. So sometimes if you go out with your telescope and it's a low power instrument, sometimes in the old days we called them rich field telescopes, just on a really dark night along the Milky Way and in other areas, just scanning the sky and moving around and seeing what you can discover sometimes unearths really interesting fields like the lovingly titled Broken Engagement Ring. Here from Ron Stoyan's Interstellarium Deep Sky Atlas is a chart that shows you where the broken engagement ring is. And that's the bright star at the base of the bowl of the Big Dipper over on the left-hand side of this chart. And of course, there's a smattering of the usual Ursa Major MGC galaxies in the area, but this is a very unusual object. Here's a sketch, telescopic sketch of the broken engagement ring made by Richard Orr a few years ago, and this was in a reasonably good-sized refractor. And you can see it has this sort of C shape or backward C shape, depending on how you view it, or arc-shaped ring of stars. Here is an image by David Ratledge of the broken engagement ring in the center there as well. And so you can see it's just a nice grouping of bright stars, very easy to see in practically any telescope, and if the sky is clear and reasonably dark. And it's kind of neat seeing these patterns of stars. That's all I have really tonight, and I can tell you the December issue of Astronomy Magazine is out there, in which Marcia Bartusiak and her colleagues are arguing in the same month that we've rededicated Lowell Observatory here in Flagstaff, that maybe the Hubble constant should also include a little love for V.M. Slifer and others who were involved in the early days of understanding that the universe is expanding before 1923, and some other stories there. There's a review of Celestron's pretty hot new product, the Origin Observatory, is in this issue as well, and a bunch of other things. And I will mention that next spring, now the dates have been adjusted just a tiny bit. It's going to be April 25th through the 29th for our next Starmus that will involve a lot of talks by Nobel Prize winners and by astronaut explorers and by scientists in a number of sciences, not just astronomy and space exploration. And of course, we'll have some rock and roll and surprising, interesting concert stuff going on there as well. So we hope you can join us in La Palma, which hosts the world's largest telescope, which is shown here, the GTC, which edges out the Twin Kex in Hawaii. for the time being, still the largest telescope in the world until the other projects that we know about are completed. And we will have a good time next spring in the Canary Islands. So consider tuning in there or joining us there, and you will have the time of your life. So Scott, that's all I have tonight. I will end the show. That's a pretty brief look at just an asterism this time, but we'll go back to the normal, more detailed looks at deep sky objects next week.
Yeah, David, have
David,
you,
I'd like to just mention how much I enjoyed that. I'm gonna have to go out and look at the broken engagement ring.
Yeah.
I have one, a broken engagement ring.
Well, there you go. You have to go out and look at it.
I have to, absolutely, if it ever clears here, which it probably will one day, but watch for a while.
Yeah.
In any event, we have, I have a broken engagement ring. It's the second of 3 that I got with my marriage to Wendy. And so when it broke, I went to Stellar Vision and they made a 3rd one. And I have it, and I'd like to show it with you. This one is not broken.
Yeah.
This is this is my engagement ring with Wendy, my wedding ring. I'm still wearing. It is a meteorite. It is a Gibeon meteorite from Africa, and I've still got it. If I lose it, if it falls off, I'm not going to replace it. But for right now, I have it, and it reminds me of 30 years of real joy. Thank you, and back to you, David and Scott.
Fantastic. Thank you, David. And thank you, Scott.
I'd like to mention also that this object is number 36 on the League's asterism observing program.
Very nice. Excellent.
Yeah, there's not a lot about asterisms on the internet.
No,
I did find something called the World Asterism Project, and they said that there's something like 270 some odd known asterisms, but you know, maybe and it seemed like some people were kind of making them up, you know, a little bit, you know, but anyways, I think that it's lovely to find something like the coat hanger, and they're like familiar friends in the sky, you know. So and I think something that amateur astronomers kind of gauge their own eyesight to see if they can see these things, and etc. So, but so it doesn't surprise me though, Chuck, that there is a observing program for asterisms out there. So, because you guys have so many. Our next speaker is Marchelo Souza. Marchelo is in Brazil. He is an amazing educator in astronomy. He is a huge outreach enthusiast, and he puts together probably the very best astronomy and space exploration convention in the Southern Hemisphere. He is always doing something with his students. He's tireless in working with the Louis Cruels Astronomical Society, and his work at as a professor at the university that he is a professor of, which I always forget the name of it, but you know, he is a very popular educator, and he's very popular with us. He is the editor also of Skies Up magazine, which will be published again very soon. So let's bring him on.
Hi, thank you very much for the invitation, Scott. Thank you for your kind words.
Thank you, Marchelo. Thank you. I'll let you have the stage.
Okay, I will share my screen. I'll talk about the experience that we have here. I think it's working now. This is our astronomy club. We have 28 years of activities. Is everything working? Hi. I'm sorry, something happened here. Okay. The presentation is not in presentation mode. I don't know what's happening. Only a moment, Schwarz. I don't know what's happening. Sorry. Okay, I will try again. Sorry. I don't know what's happening when I try to share. I'll try again. Can you hear me, Schwarz? I'm sorry. I hope it's working now. It's not working. I don't know why. I'm trying something different here on a moment. I'm sorry. I'll do something different. Okay. I hope now it works. I'm sorry because it's the best that was possible for me now. I will show the image. I'm sorry, Scott. Can you hear me, Scott? I don't know what's happening here. I'm sorry. Can you hear me, Scott? I can't hear you. Hi? Okay. Can you hear me? I'm not hearing you. What's happening? I don't know what's happening.
Can you hear me, Marcelo?
Yes, yes, I can
Okay,
hear you.
I can hear you at least. I don't know.
I can hear you as well.
Okay.
Okay, thank you. I'm sorry for the problems here,
Sure.
but I think that I found a way to show. In a few minutes, I will show. But I will talk about our experience with the popularization of science here. And we had the opportunity to participate in two special events here the last week and about the astronomy in schools. And at these events, we students produced amazing uh, experience of the popularization of science for the public. I will try to show this. I'm changing here my
Marcello,
presentation.
we could see your presentation
Yes, but for
last
me, it was blinking.
is
I don't
blinking.
know. Yes, I don't know why.
There were like these
Because
gray squares in front of it, so I'm not sure
yes,
what that was from.
I don't know what's happening. I'll try again, but I save in a different. I'm trying to save now in a different format, and I think
Okay.
that will be possible to show. But uh, I don't know what's happening. I'm sorry, Scott. My computer, unfortunately,
It's
sometimes
okay.
don't.
Sometimes it doesn't behave.
Yes, they don't want to work.
Understood.
You're not alone in the world.
That's right.
We've
That's
all
right.
had these problems.
Yes.
I don't know why, but I changed here for PDF. I think that will work. And today, my football team is playing the most important game also.
Oh, okay.
Yes, we are trying to be the Brazilian won the Brazilian Cup. I'm here. I have now in PDF. I hope that works. I'm going to share. I'm going to show in big screen, but I will share now. Let me see if it works. Hmm. For me, it's okay. And for you, can you see?
Not quite yet, but let's give it a minute.
Okay. I don't know what's happened. My internet is okay. I think that problem is with my computer because internet here is fine. And it's not blinking for me. There's something good.
Hmm.
Eh,
It's still, it's
you
still
can't
not
see?
coming. No, not yet.
I don't know what's happening. I'm sorry.
Oh, wait, here it comes.
Okay.
Uh,
Oh, something is different here. I don't know.
Perhaps a lot of your countrymen are using the internet to watch the football match.
Yeah.
yeah, that's what it is.
Maybe it's the most important game today
That's what it is.
because this is it's not the last game of the Brazilian Cup, but it's the most important because if my team or the other team wins, they are almost will win the Brazilian Cup
Yeah.
because they are the. Can you see now?
It's white. We can see
Okay,
some graphics, but now we see it. Now we see it.
okay.
Yes.
Let me see. I will try to change the screen.
Okay.
Okay, let me see if it will change. But it is allowing me to edit. Okay, it changed.
There you
This
go.
is the Brazilian. I will begin with the Brazilian most famous poet. That is our Shakespeare in Portuguese. It's not a Brazilian, it's a Portuguese. His name is Fernando Pessoa. Here it is in Portuguese, but I will change now for a free translation of this part of the this that you are talking about the universe. He said that the universe is not my idea. My idea of the universe is that it is my idea. The night does not grow dark through my eyes. My idea of the night is that it grows dark through my eyes. Outside of my thinking and of having any thoughts, the night grows dark concretely, and the brightness of the star exists as if it had weight. He wrote a famous book that is someone that take care of the cows and of the animals, and with one of the names that he used as a poet. And he's our most Brazilian, not Brazilian, but poet in Portuguese. Now I'll try to show images of our events. But I don't know what's happened because my computer is blinking. I don't know if you can see
Yeah, and
the.
the screen is dark.
I don't
Here he
know.
is again. This is the image of Fernando Pessoa.
Yes, I am trying to change here. Let me see what's happening. Here. Can you see
There we
the
go.
image?
Yes,
This was
see it
an
very well.
event that we participated in a famous school here in our city, and they have an observatory there. And the observatory, we now know that it was the first one in our region in Brazil. It was built in 1960s, and they rebuilt the observatory 3 years ago. and we help them to uh, know about the history of the observatory. And we are working with them there. And this was a ceremony that we receive a plate because of our efforts to uh, find all the history about the observatory in our region in Brazil. These are the students from this school that likes astronomy. They are the new generation of students here that will be working with us. And we had another event that's a very special one in a school in other cities, not in our city. And we had participation of a lot of students, and they organized a day of astronomy there. All the students of the school organized, they have different classes since from the kindergarten until the last year of the fundamental school, that here is the 9th grade. They organize special events, and they have special rooms for each class. And I had the opportunity to make presentation for them. And this is part of the students. And here with Yuri Gagarin, right? They had an image of Yuri Gagarin in natural size there. And they organized many different rooms to talk about the history of astronautics, about astronomy. And it was a fantastic experience for me in this seat. You can see here. Elon Musk was there also. Né? They have an image of Elon Musk there. And also about the history of astronomy. They organize a special, the room of the history of the telescopes. And they put us in a big screen here, famous astronomers, né? And including the name of our astronomy club, that is Louis Cruz. That the name of our astronomy club is in honor of Louis Cruz. That was the second director of the National Observatory. Here is Louis Cruz there. For us, for me, it was a surprise that he was there. They talk about his history, and they also these are the teachers and director of the school, and they organize many things, a fantastic exhibition there. And I'll show now the last image that I had the opportunity to take using the Las Cumbres Observatory. We are studying comets. These are image of the comet C 2023A3 from this observatory. This is the comet 333P. This is comet 29P that had an outburst last week. It's very far from Earth, and they detect an outburst.
That's cool.
This is a image that I got from the Unistellar. That's a blue flash nebula, and you can see that it was only 5 minutes of image that it was possible to resist this fantastic object. And also the NGC 0091, 891, 91. Only 5 minutes, but I will take another picture with a longer exposure. And I'll talk something that you're talking about William Herschel, and on he had the opportunity to discover the infrared. I don't know if someone talked about this, and this is a fantastic experience, a simple experience that he did, that he had the white light, and he used a prism or to separate different wavelengths, and using a thermometer, he noted that after the red, he also had a high temperature there. and this was fantastic discovery. And in 2009, the ESA launched an space observatory in honor of Herschel, and it was studied the universe, and one of the specters was the infrared. These are fantastic images from these space telescopes that worked from 2009 until 2013. This is the Orion Nebula in infrared from
Wow.
the Herschel Space Telescope. This is another galaxy, and something that is fantastic to know that we had in space and space observatory in honor of William Herschel. That for me is a fantastic astronomer, and he also a fantastic musician, because until, if I'm not wrong, he was 44 years old when he began to work with astronomy. Before, he was a musician, and a fantastic musician. And here is my team that has a star. This is symbol of my football team here in Brazil. That
Ah.
name is Botafogo. That we call Patifire. And now the owner of my team is an American. That is John Texor. That he and now this is the two most important players of my team. And I hope we will win today. We now is 1-0 for us. I hope that you have probably more 30 minutes of game, and I hope you will win, and you will be the next winner of the Brazilian Cup. Thank you very much for the invitation, Scott. I
Thank you so much,
apologize for
Marcelo.
the problems that I had here,
Nah, it's okay. It's happened to
and
everybody.
ever is a great pleasure to be
It's
here.
happened to all of us. Thank
Thank
you
you.
so much. Thank you. Okay, all right. So, David, our next speaker is Chuck Allen. And Chuck is the current president of the Astronomical League. I met Chuck years ago at an Alcon event, and he was explaining to me about the, I think then new recognition award for the National Young Astronomers Award. And so it's been a pleasure to be involved with that over the years. And I think that seeing these brilliant young people come forward and do really stunning research level type of work is just, when you learn about what they do, there's really, it seems that just recognizing them for it seems to somehow fall short of what you would like to do, which is, afford them every opportunity to really excel in their lives because they have so much to offer. And so let me bring you on, Chuck. Thank you very much for coming on to the Global Star Party.
Always a pleasure, Scott. Thank you. And with regard to that award, the reason it's now in its 33rd year is largely because of Scott and Explore Scientific's support of the National Young Astronomer Award program, which garners 10 plus of the most incredible research projects that you can imagine coming from high school students. Just truly remarkable stuff. Is my audio okay before I begin?
Yes, probably
Okay.
much better than mine.
Actually, yours is okay now.
Okay.
Okay, so let me share screen here and we'll get started. Okay. Maybe Marcello's not there. Oh, never mind.
There we go.
Okay, there we go. I just got back from New Jersey. I left New Jersey yesterday morning, got home last night. visiting my lifelong friend, Richard Gott, who's a retired astrophysicist, professor emeritus of astrophysics at Princeton University. And Richard is clearly the most interesting human being I will ever meet in my entire life. And it was a great visit. Richard is an author of multiple books. He's working on another one now. Yeah, all of them incredible reads. I've had the privilege of doing some editing for him on a couple of these, and it's really they're remarkable works. He recently, because he's aware of the element collection I use in many of the talks on cosmic origin of elements, we had been joking about this 4-inch tungsten cube that exists. And we were always joking about what it would be like to watch the poor the UPS driver or FedEx driver arrive with a box no bigger than one you'd put a softball in that weighs 42 pounds. And having to use a dolly to get this tiny box up to the door. But Richard made sure I had one. Unbeknownst to me, he decided to give me one. And so this is it. It's 4 inches square cube and weighs 42 pounds. It's as heavy as my entire optical tube assembly and its Losmandy plates. It's incredible. This is at Peyton Hall, the Department of Astrophysics at Princeton. This is Richard's map of the universe, which is an exponential rendition of the entire universe from the center of the Earth to the cosmic particle horizon on the other end. And it's on a carpet in the hallway. Nearby is Grover's Mill, which of course was the ostensible location of the War of the Worlds beginning in the famous Orson Welles 1938 radio broadcast. And Dr. Einstein's house, of course, at 112 Mercer Street, still in excellent shape nearby. This is a view you may have seen in the movie Oppenheimer, which I took. I walked down the hill behind the Institute for Advanced Study in Princeton, beautiful location. The pond, I think they cut down some of those weeds so you could see the pond in the movie. This is Olden Manor, which is right next to the grounds on which the Institute is located, and that's where Dr. Oppenheimer lived when he was director there. And Richard loves scale, models to scale, and it's always a fascinating thing to see some of the things that he's collected. I won't bore you with a lot of that, but over on the left there is a 3D chess game, and we played a 6-hour game with that ended in a draw. I had an advantage on a minor exchange. I had 2 rooks to his 1, but he had a pawn position that was dangerous, and so we called it a draw at the end of that. But it was a very intense thing to play chess in 3 dimensions. It requires a change in thinking. Anyway, I wanted to talk tonight about the Magellanic Clouds. And this is something Marchelo certainly gets to see, and most of us don't unless we go to the Southern Hemisphere. And this is a view of the clouds seen from ESO's Paranal Observatory, where they have 4 1.8 meter reflectors that are separated by some distance. That creates an interferometer, which gives these telescopes, when they operate together, some 25 times better resolution than any other telescope in the world. The Magellanic Clouds themselves are pretty tight to the south celestial pole, as you can see here. They're within 20 degrees of it. For that reason, you have to be, if you get to the equator at just the right time of year, you can see them very low on the southern horizon, but no higher than 20 degrees, and only perhaps in November or December of the year. But the further south you go, obviously, they become visible as circumpolar objects. And therefore, the further south you go, the better chance you have. Well, it's interesting, first of all, to figure out why they're called the Magellanic Clouds, because I think we can safely assume that there were ancients who saw these many thousands of years before Magellan did. In fact, in Chile, they found petroglyphs with indications that suggest that they were the Magellanic Clouds. Ibn Qutayba in Iraq in about 880 AD noted something he called the feet of Canopus. And if you look on this chart, here is Canopus, and he may have been referring to these as the feet of Canopus as early, again, as 880 AD. Al-Sufi, in his book of Fixed Stars in 964, also made a record of them. The trouble is, these ancient sightings and Persian and Iraqi sightings were not reported to Europe in those days, and Europe dominated the world of science at that time. During his voyages from 1499 to 1502, Amerigo Vespucci, an Italian who sailed for Spain and who proved that the New World was actually not part of Asia, but a fourth continent, actually a fourth and a fifth continent in the world. And he wrote a letter after he returned in which he referred to canapes. And it seems likely that he was referring to these objects, although again, it was just in a private letter and it didn't get reported to the scientific community. However, enter stage left Ferdinand Magellan, a Portuguese explorer who made 2 voyages into the Southern Hemisphere on behalf of first Portugal and later Spain. Now, that raises an interesting question because Portugal and Spain were at each other's throats quite often and had to enter into a treaty called the Treaty of Tordesillas in 1494, in which they basically divided the world into 2 parts, 2 hemispheres. The Portuguese took the part you see on the left here, Africa and Asia, and the Spanish took the Pacific and the Americas. You'll notice that the meridian cut off the Brazilian portion of South America, which is why Brazilians speak Portuguese and the rest of South America speak Spanish. So Magellan, financed by King Manuel I of Portugal, sailed on a very lengthy voyage from 1505 to 1511, going east through the Portuguese hemisphere to the Moluccas in Indonesia, the Spice Islands, and then he returned by the same route. Well, he wanted to do a second voyage. He proposed doing a voyage like this, trying to reach the other side of the world via the Spanish hemisphere, and then return by the original route he had taken before. And Manuel I didn't want to finance it. So Magellan did the unthinkable. He went to Charles V in Spain and tried to sell him on financing such a voyage, a circumnavigation, he said, of the world along the route you see here in black and yellow, and told him that, hey, maybe we'll find out that the Moluccas are actually in the Spanish hemisphere. And that pleased Charles V, who then financed it. Predictably, Manuel I was not pleased. Manuel seized his properties in Portugal, raised some of them. He sent assassins to try to kill him in Spain, and even had a fleet chase him down when he began this voyage, sailing for Spain, but he was unsuccessful in catching him. So this second voyage from 1519 to 1521 led him across the Pacific and to the Philippines, where he tried to impose Christianity on a number of tribes there. Some of them were recalcitrant, and some battles resulted, and Magellan was killed in 1521. He was stabbed. The crew, however, completed the voyage, the circumnavigation along the yellow route you see here, and one of the crew members during the crossing of the Pacific had made an official log note of these clouds in the Southern Hemisphere sky. And that became part of the official record that was entered into science in Europe. And so the clouds ended up being named the Clouds of Magellan, or the Magellanic Clouds. Also, Magellan was credited with the first circumnavigation because if you put his 2 voyages together, he's been all the way around the world completely. So he gets the credit for that. A little bit later, Bayer in his Uranometria referred to these as Nubecula Major and Nubecula Minor, and Lacaille in 1756 referred to them as the large cloud and the small cloud. And so the term Magellanic Clouds came into existence. John Herschel in 1847 went to South Africa and began charting objects, open clusters, globular clusters, and planetary nebulae. found 919 of them in the Large Magellanic Cloud, seen here, and 244 of them in the Small Cloud.
Jeez.
The distance was determined largely because of the work of Henrietta Swan Leavitt, who in 1912 determined that Cepheid variables could be used as standard candles, sort of like knowing if the period of a Cepheid tells you how bright it is intrinsically, like a 60-watt bulb or a 100-watt bulb. And with that information, when Cepheids were found in the Small and Large Magellanic Clouds, the distance could be determined. And Egenar Hertzsprung in 1913 was the first to use this data to try to determine the distance to the clouds. He came up with 30,000 light years, which was short, but Harlow Shapley refined the Cepheid variable information or data that was being used and got correct answers. The large cloud is 160,000 light years away, and the small cloud 200,000 light years away. And these were thought to be the closest galaxies to the Milky Way until the Sagittarius dwarf elliptical galaxy seen here was discovered in 1994. That's just 30 years ago. And here is an image of the Sagittarius dwarf beneath the Milky Way, seen here, this slightly illuminated oval area. And you'll notice there's a bright dot right in the middle of it. And that bright dot is thought to be the core of the Sagittarius dwarf galaxy that has been attracted to the Milky Way. And guess what that core is? None other, than Messier 54, globular cluster on the M list. It's thought to be either the core of the old Sagittarius dwarf galaxy that approached the Milky Way, or to be a globular of the Milky Way that fell into the core of the Sagittarius dwarf elliptical. Either way, it's a little bit more interesting than you may have thought before. Size-wise, you see the relative size of the two clouds here. The large cloud's about 32,000 light years in diameter. That's about a third the width of the Milky Way. The small cloud, smaller at 18,900 light years. And that makes them pretty large in terms of galaxies in the local group. Andromeda, the kingpin, Milky Way, and M33 come in second and third, but the large cloud is the fourth, and the small cloud, the sixth largest galaxies out of over 50 in the local group of galaxies. Now, the interesting question is this: are these clouds companion galaxies to the Milky Way or not? Astronomers long assumed that the clouds orbited us for a long time, but they appear to be too close, and they look like disrupted barred spiral galaxies. And so there was some debate as to whether they were companions of the Milky Way. And in 2006, Hubble Space Telescope studies found that they seemed to be moving a little bit too fast to be companions of the Milky Way. In other words, they're zipping on by with a speed that would be inconsistent with them orbiting. Either that or the Milky Way is more massive than we thought before, and they are orbiting. Therefore, in order to stay in orbit, they have to move faster if we're more massive. It's not clear which is true. And so this is still a study subject right now. It is possible these objects are on a first approach to the Milky Way. Whether they would be captured or pass on by, or whether they are in fact in orbit around a more massive Milky Way, remains to be determined. Not entirely clear yet. What we've discovered since then is that the large cloud, seen here as the bright white spot, and the small cloud have left behind a stream of neutral hydrogen called the Magellanic Stream. It was discovered in 1965 and was determined to be related to the clouds in 1974, and it spans 180 degrees of the sky. It's 600,000 light years long. And if you run back in time, it shows you the path that these two objects have taken, which seems to be coming from deep space. And you can notice that the large cloud appears to be pulling the small cloud along with it, and the small cloud's giving up gas, which is forming this long stream in the back. But there's also a leading arm that you see in the upper right here. And the hydrogen in this leading arm that approaches the Milky Way was found by observing the absorption of spectra from distant quasars. And this leading arm comes within 90,000 light years of the Milky Way. and culminates with a cluster of stars called Price-Weyland 1, which is 90,000 light years away. Also, it appears that the small cloud, as it's being dragged along by the large cloud, has split into two, and behind it is something called a mini Magellanic Cloud. You can't see it here because it lies behind the small cloud, and it's about 15,000 light years further away from us behind the small Magellanic Cloud from what you see here. Well, there's also a fact about these two clouds that's different from the Milky Way, and that is that the stars in these two clouds have much less metal in them than the stars in the Milky Way. They're gas rich, and so there's a substantial halo of gas. It's called the Magellanic Corona around the Magellanic Clouds, and it's quite large, as you see in this diagram. Well, focusing first on the large Magellanic Cloud, you can see how it might be regarded as a disrupted barred spiral. In fact, it's categorized as an SBM, which means spiral barred Magellanic type. It has about 20 billion stars in it, shines at magnitude 0, about 11 times brighter than the small cloud, and its area in the sky is roughly equal to the bowl of the Big Dipper in terms of size, and it rotates about the same speed that the Milky Way does, once every 250 million years. It lies in the constellation of Dorado, with some of it in Mensa, and its most prominent feature that you see here is the Tarantula Nebula. And the Tarantula Nebula is the most active star-forming region in the entire local group of galaxies. In fact, if it were moved forward to the distance of the Orion Nebula, it would shine at magnitude -3 and cast shadows, if you can imagine a nebula doing that. If you look in the core of the Tarantula Nebula, you will see a star cluster that is formed from the gas in that cluster, and the radiation from which is now creating a hole in the nebula. This is the R136 star cluster. There are about 60 globular clusters, 400 planetary nebulae, and 700 open clusters in the large cloud. A couple of the largest globular clusters are seen here, NGC 2210 and NGC 1783. And here's a rich star-forming region in the large cloud called LH63. And here you see two rather interesting star-forming regions, one clearly an emission nebula on the right with bright young blue stars exciting the hydrogen gas in the nebula. And then this one over here, which is more of a reflection nebula with some emission characteristics in the pink that you see there. Now, the large cloud produced a show for us. In February 24th, 1987, it gave us the brightest supernova seen from Earth in over 4 centuries. And it was a blue supergiant that exploded, and it reached magnitude 3 and remained visible in amateur telescopes for over 2 years. Even 2 years afterwards, it was shining at magnitude 12 or 13, as you can see here. So that was quite an impressive and important discovery. Interestingly, neutrino detectors around the world detected the supernova explosion about 2 to 3 hours before the light increase was detected. This is caused because the core collapse of the star created the neutron, the neutrino flux rather, before the shock wave erupted through the surface to begin increasing the brightness. The Kamiokande neutrino detector in Japan picked up 9 neutrinos in 1.9 seconds, and 3 more 9 seconds later. The Irvine, Michigan Brookhaven detector picked up 8 neutrinos, and the Baksan, Russia detector picked up 5 neutrinos. That doesn't sound like a lot, does it? But they detected it nonetheless. Now, the star, before it exploded, in fact, 20,000 years before it exploded, ejected some surface material that expanded out away from the star. And when the supernova exploded, the shock wave from the supernova eventually reached that gas envelope and caused it to illuminate brightly like a giant ring. And here you see that happening over a period of several years. The resulting image was spectacular. This is a moment when it was at its brightest, the shock wave hitting that previously ejected sphere of material. And here's a better view of it, showing in the center the dust left over from the original explosion. Now, it's not the only supernova, certainly, that's ever gone off in the large cloud. But when it went off, the light from the supernova reflected off of the nebula in the background and created these concentric rings called light echoes. Here is an older supernova remnant in the Large Magellanic Cloud. And here's an even older one. Looks a bit like the Veil Nebula or the Gum Nebula. Okay. Well, that takes us to the Small Magellanic Cloud to finish up with. And the small cloud is right next to, or seems to be right next to, the famous globular star cluster 47 Tucani. Now that globular cluster 47 Tucani is actually 15 times closer to us than the small cloud. It's an interesting globular, to say the least. It's the second brightest in the sky after Omega Centauri, about 44 minutes of arc across, shines at magnitude 4, and may have a black hole in its core. Now, the small cloud is regarded as a dwarf irregular DI class galaxy, but is believed to be a badly disrupted barred spiral, more disrupted than the large cloud because the large cloud's dragging it along and kind of helping destroy it. It only has about 3 billion stars in it and shines at about magnitude plus 2.7 and would fill about a third of the bowl of the Big Dipper. And its brightest nebula that you see at the bottom here is NGC 346. And here's a closer view of that emission nebula. And NGC 376, an open cluster, can also be found in the cloud. And so you find this particular cloud, the small cloud, in the constellation of Tucana, the Toucan in the southern hemisphere. The combination of these clouds makes the Milky Way a very complex system indeed. We have X-ray bubbles on either side of the central disk of our galaxy. We have the Sagittarius dwarf elliptical that's whipped around the galaxy, leaving streamers all around. We have a host of dwarf galaxies surrounding us. And we have the Large and Small Magellanic Cloud with its leading arm approaching us and that stream draping behind it for 600,000 light years. Now, it's entirely possible that the Large and Small Magellanic Clouds used to belong to Andromeda, and Andromeda passed right by us about 10 billion years ago. And it's possible that we stole these clouds from Andromeda. But as we know, Andromeda is making a U-turn and is heading back and will collide with us in about 4.5 billion years. But it's just possible that Andromeda is coming back because it wants its clouds back. In any event, that's something for you to look forward to seeing if you go to the Southern Hemisphere. And I certainly encourage it. Thank you, Scott.
Wonderful, wonderful. You know, the first time I saw the Magellanic Clouds, I was surprised at how big they were in the sky, because you see these kind of wide angle shots and it looks like these two little things out there. But when you're standing there underneath the, the Milky Way and staring at them, they look quite large, and that was my takeaway from observing them from Chile. So, but I recommend to every astronomer, every amateur astronomer, you got to get down to the Southern Hemisphere. Okay, this isn't like a wish or a bucket list kind of thing. If you really want to experience the Milky Way, you got to get down there and see it for yourself, because it defies description. It is spectacular, beautiful, and awe-inspiring. And go down there once and you'll know what I'm talking about. So anyways.
Me too, Scotty, thank you. I just want to make a comment. Chuck, your lecture moved me to tears. I was sitting, and as I'm listening to your excellent presentation lecture, I went back in time. I found myself sitting next to Henrietta Leavitt over 100 years ago as she was measuring the change of magnitudes and the Cepheid variables, and developing the period luminosity relation, for which he is now so famous. Then I found myself sitting next to Brian Marsden as he turns on his computer and realizes from a report that there is a supernova in the Large Magellanic Cloud. And I just wanted to tell you that you moved me so much with your lecture. Chuck, congratulations.
Well, thank you very much, David. I really appreciate that. Coming from you, that's overwhelming. Thank you.
Well, thank you, although I need to tell you also that I am definitely not infallible. Last weekend, I made a report of a star to the north of the Orion Nebula that had suddenly brightened by a magnitude and a half. And that was very exciting till the next night I realized that the star was south of the nebula and not north of it. And so I made a correction to that report. And that worked until the following night, the third night, when I realized that that star was not brightened at all and that I was just careless and I made a mistake. So I had to print a retraction of the whole thing. So, the great David Shakespeare is not so great these days. But I do think that your lecture was absolutely memorable. I'm going to think about it for a long, long time.
Well, thank you again. I'm deeply moved. Thank you.
Okay, all right. Well, David, our next speaker is none other than Robert Reeves. Robert is, for those of you who watch Global Star Party, you know that Robert is an expert on the moon, but he's also a renowned astrophotographer. He's written books about it, and he is, once you start to see some of his lunar astrophotography, you'll understand just how amazingly skilled he is. He has got decades of experience to share. To me, he's the David Attenborough of the moon, and that's my nickname for him. And he inspires all of us to explore the moon and to understand, and to learn more about crater formation, the seas of the moon, and all of its amazing structures that you can see. And so, if you didn't like the moon before, well, he'll make you fall in love with it. So, Robert, thanks for coming on to Global Star Party.
You bet. And that little nickname you gave me, the David Attenborough of the moon, apparently a lot of people watch this Global Star Party because I am being introduced at other events as the David Attenborough of the moon. So your little moniker is it's stuck.
It's true. It's true. Hopefully one day David Attenborough calls you and
yeah, it's with a cease and desist letter probably.
Who knows? All right.
Well, anyway,
it's true. So all right. Thanks so much for coming on to Global Star Party.
Right. Well, I traditionally talk about the moon, and it's usually peppered with a lot of my photographs, but tonight we're only going to see two of them. We're going to concentrate mainly on a moon map created by the Lunar Reconnaissance Orbiter. We're going to explore the Artemis 3 landing sites. Now, everybody knows about Tranquility Base, where Neil Armstrong first set foot on the moon. So the Apollo 11 site is immortalized in print and in film and just throughout history. But soon, and no earlier than late 2026, there will be a seventh landing site on the moon. And it's going to be near the South Pole. And we're going to explore these areas. There's 9 candidate sites. And Rusty, the famous moon cat, is sneaking into my field of view over here. So she may be making sure that I'm telling the truth to everybody. But before we jump in there and explore these Artemis sites, the 10-penny commercial, of course. If you love the moon, if you know somebody who loves the moon, and you're wondering what for Christmas, I have got to put up my book, Photographic Atlas of the Moon. It's available from Firefly Books at brick and mortar bookstores, and it's also available on Amazon. So consider that if you have a moon lover in the family or know one that you want to include in your Christmas gift. So with that said, let me go to share and let's bring up the moon. Now, the 6 Apollo landing sites, Apollo 11 through Apollo 17, all concentrated on the near side of the moon, of course, in the equatorial region of the moon. And I hope you can see my cursor moving around, basically in a broad band, boxed in by the Tranquility Base, of course, at the southern end of the Sea of Tranquility, Apollo 12 over in Oceanus Procellarum, 13 didn't make it, but 14 landed near the northern part of Mare Nubium. 15, of course, into Hadley Rill up next to Mare Imbrium. 16 landed just north of Descartes crater, and 17, the final one, at the Taurus Littrow Valley on the other side of the Sea of Serenity. Now, all of these lunar landing sites that Apollo visited are pretty much below mean lunar elevation, with the exception of Apollo 16. The Apollo 16 site at Descartes craters, basically at lunar sea level, mean lunar elevation. All the others were significantly below mean lunar elevation. But the Artemis sites, we're going to touch down near the moon's south pole. First one going down, going to be a SpaceX Starship. Like I said, no earlier than late 2026, more than likely a little later. SpaceX is making good progress getting this thing to fly, but it's got a ways to go. We've got to make it utterly reliable for human beings. So there's a lot to be done prior to the Artemis 3 landing site. But once we do get to the moon and land near the South Pole, the landing site locations are kind of hard to see from the Earth. The lunar South Pole is a difficult target in a telescope. The best way to find the actual lunar South Pole, go to Moretus Crater, a very well-known large Copernicus lookalike down along the southern the southern limb, and then there's a whole series of Newton and Newton A, B, C, D craters that extend south from it, and the combined rim of these Newton craters points more or less toward the South Pole, and when the libration is right, that is when the moon's South Pole is tipped toward us, we can just begin to see the lunar South Pole, and this little sliver floating against the darkness here is Malapert Massif. That's one of the Artemis landing site candidate locations. The others are all nearby, but our extremely foreshortened view of this region of the moon from the Earth makes it extremely hard to see on a telescope. Wherever Artemis 3 lands, we're not going to be able to point our telescope directly at it like we do to any of the Apollo sites and show them off at star parties and say, that is where man landed on the moon. It's going to be tough finding these Artemis sites, South Pole Artemis sites, in a telescope. But let's take a look at this map. Composite images from the Lunar Reconnaissance Orbiter all around the lunar South Pole. We see these various landing sites all around. They differ significantly from the Apollo landing sites in their elevation. These are some of the highest places on the moon, whereas Apollo landed in some of the lowest regions, just by chance because they were flat on the Mare, where it was a safe landing zone. Artemis is going to the South Pole necessarily for the idea that in this region it will be in perpetual sunlight. You notice a lot of these high peaks are very brightly lit next to a very shadowed area. That's because these peaks protrude high enough that no matter where the sun is along the horizon, it's still shining. Perpetual sunlight at the South Pole lunar base is one of the key features of the landing sites. But let's take a look at some of these. The peak near Sabaeus B, this one here. This territory rises 6 kilometers over a 30-kilometer span, changing in elevation from about 2,900 meters below mean lunar elevation to about 3,850 meters above. And the site is about 120, about 200 kilometers from the South Pole, and it's one of the most distant from the southern pole of all of the Artemis sites. Haworth, seen here in this box. This particular site features a peak rising from 2,900 meters below mean lunar elevation up to 5,400 meters. Excuse me, I'm reading the feet, not the meters. We have a very international audience, so I want to stick with meters, to 1,650 meters above. And this location provides perpetual sunlight. Massif, the little sliver that we saw in the picture that I had taken from my own backyard, that little sliver is this illuminated ridge. And Malapert Massif is mentioned often as a Artemis 3 landing site, but I am betting that we're going to land somewhere else, and I'll tell you about it in a minute. But anyway, Malapert Massif is a broad region that rises about 5,000 meters and provides perpetual sunlight, but it also descends 8,000 meters toward the pole, toward permanently shadowed regions. Now, these permanently shadowed regions are where we hope to find ice on the moon. And ice, in addition to perpetual sunlight, are two key elements that future moon bases need. The ice to create oxygen and water, the perpetual sunlight to provide power. The Mons Mouton Plateau, that's this large region here. This is where I'm betting Artemis 3 will touch down. Now, this is the widest and overall flattest of the Artemis sites, varying between just 5,000 and 6,000 meters in elevation and across a 60-kilometer span. Now, the plateau is high enough to receive perpetual sunlight and broad enough to allow expanded explorations with the Artemis 4 and 5 missions, where they will be using long-range rovers. So the broad expanse is fairly flat, is what's attracting me. So it gives a much broader area to explore. Instead of being a mountain climber, you can rove over large regions with relative safety. Mons Mouton, right on the rim of this plateau. It's a peak that rises 6,000 meters, and then descends 5,000 meters toward the South Pole. Again, access to ice, access to perpetual sunlight. Nobile Rim 1, Nobile crater here, Nobile Rim 1, the southwestern. You have to remember that everything is inverted here because the South Pole is here, and we're not looking at the North Pole, but the South Pole. But anyway, the southwestern rim rises about 3,000 meters. So again, perpetual sunlight. And then rim number 2, same crater, again, rises um, up into perpetual sunlight, but it's the second lowest elevation of the Artemis candidate landing sites, actually being 1,400 meters below mean lunar elevation. Degerlache Rim number 2, the 8th candidate landing site. It's the closest to the pole, only 50 kilometers from the true pole, and it rises about 3,000 meters. So again, perpetual sunlight. Then the final Artemis candidate landing site, the Slater Plain. It is the lowest elevation of all of the Artemis sites, with rolling hills descending from east to west from about minus 1,800 meters to minus 300 meters. So sometime in the next 3 years, we are hoping that one of these sites will host the next manned landing on the moon, and probably multiple returns to the same region. The plan is that Artemis will attempt to fly a landing mission about once every year, once things get going. So assuming the budget holds up. So very soon, one of these sites will be joining the 6 Apollo sites that everybody knows about. And let me see if I didn't skip a slide. Apparently, I do not remember showing. Did I show that slide? Yes, I did. I kind of skipped over it a little bit. And one of the primary safety things is, of course, it must be a fairly flat area where they touch down. I am crazy about all of the designs that we see for the Starship human landing system. In my thinking, yes, it's going to weigh more, but my thinking is those footpads should be spread out more. I mean, this is landing this is landing a skyscraper, landing a pencil on this tiny footpad pattern compared to the size of the vehicle. One thing that concerns me is that there's evidence that near the South Pole there may be moonquakes. And if this place rocks and rolls, we've got to have a pretty stable base underneath those starships. So I am thinking that eventually, by the time this thing touches down at the moon, that landing leg configuration is going to be a little bit bigger. I mean, let's face it, even the Falcon 9s that come down and land on the ocean on their barges nowadays have a more robust appearing landing legs than this one does that's landing on the moon. So the basic configuration will stay, but I am betting we'll see a larger landing gear on this thing by the time our boys make it up to the moon. Now, the size of this thing, it's staggering. Bear in mind, this thing is about 160 feet long. This is like putting a 16-story high building on the moon, or landing it on the moon. Right around the lower part of the black banded area at the top is the airlock and elevator. When they open the door to get on the elevator to descend to the lunar surface, they are 100 feet above the moon. My gosh, when Apollo was landing, they were still braking. They were still under power. They were still trying to slow down at 100 feet. So this is a significant jump in architecture. But it's going to happen soon, and I'm happy to see that it might indeed happen while I'm still around. I'm 78, and I think I'm in pretty good shape. I expect to be around when Artemis 3 touches down, and I'll see our return to the moon after well over half a century. But it's going to be at one of these 9 sites, and as we get closer, the site selection will be refined, and we will know where the 7th manned landing on the moon will occur. So it's been fun. I hope I've showed you a part of the moon you haven't seen before, mainly because our slant angle from Earth, we simply can't see this region in a telescope. But we're going to become very familiar with it when Artemis finally lands on the moon. So let me
Excellent.
unshare and go back
A couple
to,
of
there we
comments
are.
here.
Robert, thank you very much on this lecture. I do have a question. I'm wondering if you could talk a little bit about the Shoemaker impact structure near the South Pole of the Moon, formerly called the South Pole Aikens Basin.
Yeah, well, it is the largest impact basin in the solar system. And it is so big that when we mapped the moon back in the 1960s with the Lunar Orbiter program in preparation for Apollo, Lunar Orbiters 4 and 5 were dedicated to science mapping, and they pretty much mapped almost all of the far side. A certain percentage of it wasn't, but we got a good enough view that we thought we understood the backside of the moon. But it wasn't until the Galileo probe went by the moon on the way to Jupiter and looked back at the moon that they discovered the South Pole Aitken Basin. It had been staring us in the face all along, so big that they didn't realize it. And now that we've got Lunar Reconnaissance Orbiter up there, and the Japanese Kaguya satellite did laser altimetry, the Clementine mission in the late 90s did a laser altimetry. And of course, Lunar Reconnaissance Orbiter has refined that tremendously. Millions of laser sounding altitude readings all over the moon. And now we can profile this massive, massive basin on the far side of the moon that literally extends from the far side lunar equator all the way down to the South Pole. And like I said, it hid in plain sight even after we had very fastidiously mapped the entire moon, and it wasn't seen until we looked at the moon from afar with a spacecraft going off to another planet. So it's so big that it hosts many other basins on the moon. The Apollo Basin lies within the South Pole Aitken Basin, and that's where the Chang'e 6 Farside sample return mission landed last summer. And the current online edition of Astronomy magazine at astronomy.com has my article about the scientific results of the analysis of the basalts at that Farside location in the southern Apollo Basin. And I've been discussing the Artemis program. I should mention that the next issue, print issue of Astronomy magazine, will have a 10-page review of my discussion about the Artemis program and the complexities of the Artemis program, and what we're facing to the technology challenges and the convoluted plan that I do not agree with to return people to the moon. My personal feeling is the lunar can be done away with. My personal feeling is the SLS, the $2 billion a copy rocket that is just going to be a taxi to take astronauts to lunar orbit, that can be done away with. A Falcon Heavy with a beefed up capsule similar to what we ferry astronauts to the space station in, could transport our astronauts to lunar orbit to rendezvous with the Starship. So a very complex layer of stuff that must succeed is being piled on top of each other to create the Artemis program. And I'm not in agreement with it. But Robert Reeves has no say at NASA. So we're going to sit back and watch the show and hope that it works. But like I said, check the next print issue of Astronomy for my 10-page article detailing how we're going to do this.
That's great. There is Mark Drexler was watching on YouTube, and he just said that he's mesmerized by your presentations, and he wants to thank you for autographing your book for him.
Yes, that was a pleasure.
Yeah, and he says for anyone that's interested in the moon, they should definitely get your book.
I agree.
That's right. Matt Ota is watching and he says, perpetual sunlight. Does that mean elevated temperatures? As you know, all the Apollo landings took place just after lunar sunrise. I would assume that NASA will develop the new spacesuits that will have the ability to keep the astronauts cool with more thermal control capability.
Well, the spacesuit being developed for the Artemis program not only has to keep them cool, it has to keep them warm. Remember, they're going to be exploring shadowed regions, looking for ice. The Artemis spacesuit, lunar suit, must be able to operate for 2 hours in a perpetually shadowed region on the moon. And these are some of the coldest places in the solar system. There are regions on the lunar poles that never receive sunlight that are actually colder than the planet Pluto. So the engineering challenges are immense, but Axiom Aerospace in Houston is producing these suits, and recently they teamed up with, believe it or not, Prada, the fashion accessory company, to help create these suits. And Prada does bring some expertise to this that Axiom doesn't have, in that they're used to working with exotic materials. They're used to fine stitchery. They're used to creating a quality stitched garment. So this is actually a good marriage. Plus, Axiom Aerospace was encountering financial difficulties, so the cash infusion from Prada didn't hurt the situation any. So whenever they step foot on the moon here in the next 3 years, it would not surprise me if there wasn't a very distinct Prada emblem on the sleeve of the spacesuit as well.
Yeah, very good, very good. Lastly, someone's asking, is there a good way to reach out to you?
Well, if you're on Facebook, you can personal message me. And if not, well, I'll just tell you my email address. It's fairly simple. Robert Reeves 400, all one word, at Gmail. Very ubiquitous email platform. Robert Reeves 400. Drop me a line if I can help you.
Great. Thanks so much. Thanks, Robert.
My pleasure.
All right, take care. All right, so our next speaker is Dr. Daniel Barth. He's an accomplished astronomer. He is educator, author. He's known for his engaging approach to making complex astronomical concepts accessible to almost anyone. He has a passion for science outreach. He inspires curiosity about the cosmos and our place within it. And he also shared his knowledge with a series of inexpensive demonstration tools so that teachers could better educate their students about the universe, the moon, the difficult concepts that take a while to try to wrap your head around these things. So he made this series called How Do You Know? And those are actually on this page. If you're going to look at the speaker schedule, you'll see a link to each one of the speakers and to their pages. Daniel Barth's links go to his How Do You Know series. So you should give it a watch. But Daniel, thanks for your patience and coming on to the Global Star Party once again. It's great to see you.
It's nice to be back.
Yeah, and I know that you're building an observatory.
I am.
And that you're having a great time. So thanks once again.
Thanks, Scott. Yeah, I just I retired last June from my professional astronomy work, and we bought a new place in the Ouachita Mountains in western Arkansas. And yesterday, I cast the slab for my new observatory. So that will be coming online in the coming weeks, and I hope some evening I will host. I will come on to Global Star Party from my observatory here, and it's quite interesting, lots of fun. And I don't do things like anybody else, so of course I considered it a dome, I considered it a clamshell, I considered it a roll off, and I said no, and designed my own kind of observatory, and maybe we'll join Global Star Party from my new observatory when we get it all finished. But it's moving forward. We're very excited. And you know, I love attending Global Star Party, and I love listening to all of the people talking about new discoveries. But I'm going to kind of take a left turn here. Discovery, we often think of, what do you know now? What have you discovered? What have you learned? What's, excuse me, what's new? The interesting thing is, there's also a group of people who say, oh, the science on this or that is now settled. Nothing could be farther from the truth. And science is something that's ongoing, that's always changing. And sometimes discovery isn't a eureka moment. Sometimes discovery takes years, decades, centuries. We're reminded of Copernicus. Brilliant idea. The sun is in the center. No proof for that occurred during his lifetime. Galileo figured it out almost 70 years after Copernicus was gone. And we think about discoveries, Newton and his theory of gravitation. And I often tell students, why is Einstein famous? Because he was the first guy in 300 years to make any correction to Newton. And you think about that, relativity is a correction to Newtonian gravitational theory. When you fly to the moon, when the Artemis program flies, when we go to Mars, we're using not Einstein, but Isaac Newton, one of the Apollo astronauts, when they asked him on live television, well, who's flying the ship? And he kind of shrugged and said, Isaac Newton's driving right now, because their craft was in free fall on its way to the moon. Discovery takes sometimes a long time because sometimes gathering evidence is hard. And what I wanted to talk about today, Scott, was life beyond Earth. We talked about, we don't call them UFOs anymore. We call them
UAPs, right?
Yeah, unexplained aerial phenomena. So we look at this and we say, gee, sometimes even the old language isn't sufficient. Have we discovered life beyond the Earth? Well, the answer is yes and no. Dr. Gilbert Levin, who we lost in 2021, he was 97, I think. He was the principal investigator, along with Patricia Straight, for the labeled release experiment on the Viking lander. And his detection experiment met every criteria set before Viking launched for a successful detection of microbial life on the Martian surface. Of course, an awful lot of people stepped in and said, no, 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 that can't be right. There's no water, there's too much radiation, the soil is too salty, and no life that we know of could exist in such conditions. And over the decades since Viking landed in 1976, and we're now coming up on what, we're coming up on the 50th anniversary of Viking in a couple of years here.
That's right. Mm-hmm.
And what have we seen? We're seeing that, gee, every time we say life can't do that, it can't exist in that much radiation. It can't exist in that low atmospheric pressure. It can't exist in environments that salty. It can't exist in environments that have that much radiation. It can't exist in areas of extreme cold. And yet, as we continue to explore our planet, we find extremophiles, things like the, I'm going to try to say this right, Psychrophiles. It means cold-loving organisms. We found organisms in Antarctica living in the ice, entombed. They've been entombed in glacial ice for perhaps millions of years. In darkness, they still survive there at temperatures down as low as minus 20 centigrade. And you say, oh, well, the Martian surface. Yes, but underground in Mars, it's much more clement. We know there are caves and lava tubes on Mars, which are not as harsh as the surface environment. And when we talk about, the surface environment is too hard, too harsh, too irradiated, we go to the Atacama Desert. Very high, very dry, very cold. Gets a lot of, since there's no cloud cover essentially ever, gets a lot of radiation. And where does life live there? In the veins, in quartz, in rocks. Rocks on the surface covered with a biofilm, and organisms living. The light gets conducted in along the veins of quartz. It filters out the UV. You're talking micro radiation events causing, a few molecules of water to liquefy. And, oh, there you go. And now we can have a chemical reaction, and now we're in suspended animation again. Is it life? Yes, it is. Would we recognize it? Only with the most sophisticated equipment. And really taking a look. What we find on Mars with the Curiosity and Perseverance rovers, we find things like mudstones. These are fossilized rocks made of very fine-grained material capable on Earth of preserving bacterial traces fossilized millions of years ago. We find carbonates, we find sulfates. The most recent discovery, rocks with these bullseye-shaped marks where you've got iron, hematite reacting with phosphates. And this kind of reaction, bacteria cause it on Earth. And every time somebody says, oh, well, that's an organic reaction, somebody else, one of our very clever geology chemists, comes along and says, aha, I found an inorganic way to do that. Okay. How many of these things do you have before you say, gosh, are they all inorganic? And something I've always asked my astronomy students over the decades, how hard do you think it would be to sterilize a planet? How hard, do you ever fear you go in to have dental procedure or a surgical procedure and they wear masks and they sterilize the room and they take out, why? Because life is hard to exterminate. It's really, really difficult to sterilize something. Did Mars have a warm, wet period long enough to generate life? All the research over the preceding decades has shown that traces of life on Earth, we push it back earlier and earlier. What are we realizing? Life formed on Earth as soon as the conditions were favorable. Within a couple of million years after the conditions were favorable, bang, autobiogenesis. Life self-assembles out of lifelessness when the conditions and the materials are there. Was Mars warm and wet at any one time? Yes. Was it warm and wet long enough? The evidence continues to suggest that long enough isn't very long at all. That autobiogenesis occurs quite quickly. And if life is established and conditions get awful, like in the Antarctic, which was once a tropical place, like in the Atacama, which has suffered from the uplift of the Andes chain and become gradually more inhospitable over the millennia, that life adapts. Life moves underground. We now think that 2/3, maybe 9/10 of the bacteria on Earth live below the surface. And you have symbiotes, some that produce oxygen, not through photosynthesis, but through other geochemical means. And so you have both aerobic and anaerobic forms living below the surface of the Earth where they never receive the sun's energy, where you've got heat energy and chemical energy from decomposition of rocks. We find life on the Earth's surface beneath glaciers, miles of ice on top, How do they live? Geothermal heat, heat from friction of the glaciers sliding, creates liquid water, creates an environment. Scott, there's a place in Antarctica called the Blood Falls. Well, what happens there? Every once in a while, water erupts out of the ice, and it's bloody red. Why? Because it's very salty and full of iron. It's full of iron that's oxidized, and we think this is seawater from the Pleistocene, 5 million years ago, that was entombed under the glacier. And heat and pressure make it periodically erupt onto the surface, where it promptly freezes. Gee, is there bacteria there? Yeah. Is it hypersaline? Yeah. Could any surface bacteria or flora or fauna live on that stuff? No.
Oh,
No, absolutely not. So we tend to be very biased. We go out and we mow our lawn and we see birds and squirrels and reptiles and amphibians in our property and around when we walk and we hike, we explore, and we think, oh, life. But frankly, most of the life on Earth is not mobile. Most of the life on Earth is not photosynthetic. Most of the life on Earth is bacterial. Bacterial are by far the dominant and most highly successful form of life. And these little wiggly creatures that run around and talk and host interesting shows on the web, we're very, very much in the minority. And I found it interesting listening to the talk earlier about perhaps we'll see somebody who's more advanced than we are. Listen to podcasts from Brian Cox, who's, of course, a professor, I believe, at Oxford. And he's a very famous fellow. And he says, well, look, it takes a long time for current population one stars to form. And it takes a long time for planetary systems to form. And it takes a long time for bacterial life to evolve into sentient life. And he says, the universe is only 13 billion years old. It takes about 5 billion years to get a solar system, get the conditions right for, solid planets in the solar system, another 5 billion years to get intelligent life. The universe is only 13 billion years old. Maybe we're one of the first. Maybe the Fermi paradox, why aren't we hearing our neighbors, is because maybe we're one of the first. Perhaps we're much more likely to meet a peer than a mentor when SETI gets that phone call. And we think about the pace of discovery. This whole thing about can we confirm these ideas, the autobiogenesis idea, Gilbert Levin's discovery, and he, like many, many, many scientists before him, passed away before his discovery was either confirmed or disproven. But I'm firmly with Dr. Levin. I think his evidence is highly persuasive. His book, Mars, the Living Planet, I think you can probably still find it somewhere on the web. Fascinating reading. He goes into all his data. And the idea of, are we going to detect life? And then we look at the great moons of Jupiter and Saturn, which we know have liquid water underneath the surface. I probably will not live long enough. But I imagine one day we will have a probe which gets very hot. We send something powered by plutonium. It gets very hot and it sinks through the ice and eventually breaks through into free water. And probably something will swim by. That will be a great day. That will not be bacteria. That will be unequivocal evidence. Will we be able to confirm the idea of life on Mars? Yes, we will, when we put boots on the ground. Someone else pointed out to me that somewhere on the moon, undoubtedly, there are fossils from Earth life. When the big meteor struck Chicxulub in what's now the Yucatan Peninsula and what's now Mexico, that was an impact sufficient to blast chunks of rock from deep within the Earth out into space. Where do they fall to if they don't land on Earth? If they escape our gravity, chances are they fell to the moon. And we know that there are Earth meteorites on Mars and on the moon. We know there are pieces of the moon and Mars that come to Earth from similar strikes. Chances are somewhere on the moon, there's a rock with Earth fossils in it. You think about that. You think about, bacteria become encapsulated. And those encapsulated bacteria are extraordinarily resistant to damage. They survive vacuum, they survive radiation. Could life be transported from one planet to another after a meteoroid strike that was massive enough? Yeah, possibly. You know, these things are not so far-fetched as they once seemed. What was Scott's, you and I are basically the same age. What was science fiction when we were kids is not so fantastic anymore.
Yeah, yeah. I mean, black holes were, for example,
Absolutely.
pure science fiction. I mean,
Yes.
they were the monsters of the universe.
And Kip Thorne and Stephen Hawking had a famous bet about whether or not they would be discovered. And now, of course, we talk about, oh, of course they are, and what size they are, and supermassive, and are there intermediate sized ones, and
Sure.
uh,
But no question that they exist.
no question at
so,
all. And yet, no one's touched one. No one's
And-
lassoed
and
one
no
and
one
put it
was
in the
talking
jar, of
about-
course. Even one of the little, could we have a pet subatomic black hole? No, probably not. It would, if we brought one here, it would fall into the Earth's core, and it wouldn't be a problem if it was one, if it was the size of a nickel. It would never affect Earth in the lifetime of the sun. It just, the surface is its mouth, and it's not big enough to consume anything fast enough to gobble up a whole planet.
Hmm, hmm. Yeah.
Um,
Extremophiles were something that were relatively unknown when we were children, you know.
That's true. That's
So-
true. I was taught by a professor that continental drift was impossible.
Oh, really? Wow.
Oh, yes.
Okay.
Oh, yes. I was in one of my science classes. One of my professors talked about the idea of the self-assembling bacterial membrane was not possible. And then that was what he was taught in his science classes. And he said, now here's how it works. And he shows an animation of the assembling of phospholipids with the hydrophobic and hydrophilic and how they assemble into a cell wall. The thing is, excuse me.
It was at the time that we were born that even like the idea that, I mean, where it was proven beyond a shadow of a doubt that Earth had actually been hit by asteroids and
Oh,
had
yes.
left craters.
Oh, yes.
You know, so
Meteor
that was
crater was confirmed in our lifetime
1960.
to be a crater.
Well, they could
Uh,
bring material here and biologics as well, and bacteria that may have been out in the Goldilocks zone, hanging inside an asteroid that had sun heating it with water in there. They're just waiting, and boom, it's on Earth, and then it had water and oceans, and there you go.
The OSIRIS-REx probe that brought back stuff from asteroid Bennu, and they're like, wow, this could have been from a water-bearing planet. I would not be shocked if I heard them say, gee, we found evidence of what appears to be biological materials in the Bennu sample. I know that if that happened, there would be dozens of people who immediately stood up to shout, no, it's not true. Every new idea was resisted, and as Ayn Rand once said, the fellow who invented fire was probably burned at the stake with torches he had taught his brothers to light. It's discovery is not usually an instantaneous process. That's why the story of Newton and the apple fascinates us. That's why the idea of Copernicus being thunderstruck by the sun is in the center and the earth is a planet. Why Galileo discovering moons of Jupiter and realizing everything doesn't orbit the earth. This is why these thunder strike, lightning in a bottle moments fascinate us. But discovery is often glacially slow, but no less worthwhile for all of that. So just going to counsel everybody, keep looking up, enjoy the sky, and be patient. And embrace the ambiguity, because it's fascinating, and it's ambiguity is often much more fun than certainty.
That's for sure. All right. Well, Daniel, thank you so much. We look forward to seeing you on hopefully the next Global Star Party. So.
Yes, I'll be back more often now that my turnkey house turned out to be a huge fixer-upper, and I've been immersed in repairs for the last 6 months. But things are getting under control, and the observatory is coming together. So I will be back, and like I said, I want to join GSP from my new observatory when we get it all up and rolling.
Very good. Very good. Okay. Well, thanks
Thanks,
so much,
Scott.
Daniel. Have a good night, and we'll be in touch soon. Okay, our next speaker is John Schwarz. He's a talented amateur astronomer. I've known him for, maybe 20, 25 years now. An incredible space artist. He blends his love for the cosmos with artistic creativity to bring the wonders of space to life. His work has also inspired others to explore the universe through both science and imagination. And I think that we've had some really interesting presentations from John in the past. He is someone that is tirelessly trying to exceed the bounds of what he can do with his telescopes, through astrophotography, through electronic assisted astronomy. And here he is now.
Hello, everybody. Good to be back.
In his purple haze.
A little chilly out here in the vacuum of space.
It's chilly here in the vacuum of Arkansas, dude. So.
I bet. Boy, that was an interesting conversation. I wanted to say things, but every time I thought about it, he called it, like the moons of Jupiter. I'm almost sure there's life in there. They're warm and under there from the friction of Jupiter tugging on them. And as far as radiation, I think they're shielded, but some creatures can handle radiation if they're
they can.
Conceived within that, sort of condition. I mean, they say if the world here, you can't get rid of life. Roaches will survive everybody, they said, but I'm not sure about that.
I don't know.
I mean, they're kind of immune to a lot of.
My mom tried to wipe out roaches when we were
Muhammad
on military
Ali.
Base housing, and it was just like impossible, So
Yeah, it's tough, and I don't like to kill things anymore, just because it's a life.
Sure.
But black widows and flies are two that
they're still on your list.
Yeah, the black widows are pretty deadly for the pets, and then flies, they carry disease and all that.
Sure.
But again, most stuff I'll just put it outside and try to save it, let it go away.
That's what I do.
So yes, I don't know if you all saw the comet, because they say, oh, the comet's here, and I've seen some in the past, and they were not as spectacular as I was hoping. But the minute
pretty good.
This one to me was one of the best I've seen, and it really was good for me because I've been very busy with other stuff right now, and just having the ability to explore from your backyard and get the result and be able to satisfy yourself astronomically, it's amazing. You're still doing it, and then with the art, it keeps me going. So you can do it all the time, not just going to dark sky sites and taking all your equipment. It's a lot of work, and you stay up for days at a time. So it can be very taxing on you. But I'm going to get this thing going because I know we're on a bit of a limit. So everybody's been good on your neck of the woods. It's not too bad. I know they had some horrible storms back east. Some people, tornadoes and hurricanes have been brutal. But not near you in Arkansas. It's been pretty calm.
Well, we've had some fairly severe weather not too long ago, we had a tornado that kind of ripped up the city of Rogers. Actually started in Bentonville and kind of scooted across and wiped out a lot of yards. A bunch of beautiful old trees got knocked down. So we get our share of weather here, but thankfully, not too many big injuries happening. So,
when I came out to California, I was like, people here, they say, our weather's not that bad, but when they get a little rain, it's bad. But back east is, lightning and tornadoes. When you've seen a tornado up close and the power of that tornado inside that area, you're done. I don't know what would be worse.
I've been in one. It was an F2, and they're painful. They are.
I mean, but earthquakes, on the other hand, let me tell you, they're no picnic either. When the ground starts shifting and the buildings moving, you're like, oh no, I got to jump. But hurricanes, they're all bad. But just think about being out, in the universe and some of the things that they deal with as far as the size of explosions, of gamma ray bursts or supernova, even a planetary nebula. It's
amazing that we survive.
I know, it's just incredible
that goes on. That's true.
We're so blessed here, protected by our Jupiter, sort of, and we're in good shape. We had the time to be able to evolve from those microbiological things and come out of the ocean, and look where we're at today. I mean, exploration has been in every person since humanity conceived the idea of, getting in a ship and going across the ocean to find a better land. And, that's the search. We'll always be looking to understand. But anyway, let me move it. So, if you've ever been out in a forest, standing there looking out at the skies, you often wonder, what's out there. And really, the way to explore it from here is you have to get a telescope. And, there's been many times I've stood over the valley and seen the Milky Way and just sat there and just wondered, man, wow, this is a miracle. I don't even see how this is possible. We're on this rock floating in space. But, we know we're part of that universe. All of our elements within us are formed from the universe, from stars exploding and all the, elements that come from it. And then eventually it forms into life, which is a miracle. But I think it's abundant throughout the cosmos. I think it's a common, it's a lot of chances. Boss wonders too. He likes to go because I always take him in my trailer and bring him with me because he doesn't want to be left behind. And he wants one thing always, is those baby bacon Boss burgers that I make him special with the 98% lean as I can get it. That's my new portable barbecue. You can see him waiting in the background. He's hungry, always hungry. Anyway, there's many instruments that you can use to explore with. And, Scott, that's one thing I love about Explore Scientific is, you literally put the X in Explore because your linoscopes range from stuff for little kids and even young children, very young children, all the way up to teenagers, adults, and the public. And then, you get into the professionals. Your equipment takes care of it all. And, it gives everyone the opportunity to explore on their own. And that's what's so beautiful about astronomy in the community is everybody shares and is helpful. And, you start getting the fever, the scope fever, I call it, where, you want this, you see that, it's like buying nice cars if that's what you're into. But I really like to travel at the speed of light and absorb the photons. The photons help with manifestation, and usually I try to upgrade my instruments along the way. So this is a typical star party. We're out. This is the big Dob. I showed this one before. Right to left, Mirko 32-inch, Jerry 22-inch, Bjorn 24, and my 28. And we were all had a wonderful night of observing that night, exploring and comparing and just pondering at how the things come together. You know, you can look at a lot of great targets with these big instruments, and it really opens up the resolution and gives you, you know, a much better view. But again, you know, these things are traveling hundreds of thousands of years to get to us, the light. And, you know, literally, you have a time machine. I don't know of anything else that you could do that you can go back in time, you know, and that's the beauty of it, because some of these galaxies, they're not even there and the light is still coming. So, I mean, that just alone is hard to fathom. You know, this is looking up and had a great star party and just had some incredible nights, you know, with that instrument in certain locations. It's unbelievable. But that, you know, doesn't stop you. You can do it anywhere. As I was saying before, you have the disease of aperture fever, of course. This is my new instrument. It's called the Leviathan. It's a 30-inch f5 slipstream. Very big unit. Very awesome to see these things and explore, you know, the solar system as well as the deep space, you know, stars. You can go way out to quasars. This is us. First light, my little buddy came with me, as I always take him, because he really likes going up there and hanging out with me and all the nice people. There it is, looking north at Mount Pinos. Very nice instrument. So most of the pictures I've created with this instrument. The ones on this particular GSP 162. Wow, 162 already, Scott. Amazing.
I know.
Now, in this, you'll notice the Leviathan is so big that I couldn't look at zenith at the time because I only had the 8-foot ladder. So I recently got the 10-foot ladder from Tall Man Ladders, which is back in action making the astronomy ladder, 8-inch rungs, which was really cool. And if you look in the background, you can see Andromeda. So that was first light under the stars with Andromeda right in the background. And you could see M33 too in another shot. But this was a picture I created using my cell phone shot a little bit. But it, you know, I had to really work on a lot of the coloring and stuff. It wasn't like that when you looked at the picture, not even close. You know, when you get back home, things to look at and explore, you can always do lunar, even through the clouds. You know,
Yeah.
these are neat little moments. I go outside with my binoculars and I take a look, or, you know, moon coming out of the clouds. Who would ever think? There's been many times where people didn't go out and observe because the clouds were there, but sometimes the clouds add a bit of color or effect and some, you know, magical quality to the image. This one was the clouds were just all thin, hazy clouds, but the sun was illuminating them like a pink, like a pastel pink, and the moon was just embedded in that, and it was worth seeing. Most people wouldn't even have looked, but look at what I created from it. Love the moon. And then it clears, and then you can look, you know, more close. And that's what's really great about exploring is the moon. I mean, you know, sunrise on the moon, certain craters cast these amazing shadows that you normally never see. Even looking at Mars, you can explore to Mars. You have to wait for it to get closer to be able to resolve, you know, some detail on the surface. But you know, it actually shows you quite a bit of detail if you get it at opposition. Jupiter, again, you know, having the bigger instrument, you can explore the belts and see the red spot. And sometimes you're lucky enough to resolve Io, you can see surface detail on that, and maybe a little on some of the other moons. Saturn, I mean, wow, can you imagine when they explored
How many people turn to amateur astronomy for a lifetime upon seeing Saturn through a telescope? I mean,
oh
it is.
yeah, it's so addictive, and it really is, when you're doing viewing real through the eyepiece. I mean, there are photons coming, and they do interact with you, believe it or not. I call it manifestation power. And I kind of wanted to win the lottery, and so I could do some programs and really do, kick up my outreach. And they brought me the telescope, the 30-inch. So I took it. I'm happy. It's an amazing gift. That's a once in a lifetime scope to get, because they're very expensive, and you don't come across those. But again, I wanted it for the ability to get people closer and show people. I might need to get an insurance policy though. So this is, a liability, so nobody gets hurt, because man, that ladder, it's 14 feet tall when you're standing up the scope. It's a monster. This was, I was looking at Saturn and talking to Mirko, and he was doing a star party at a big, one of those resorts in Palos Verdes, and they were looking at Saturn and the moon, I think it was. Boy, your 16 was really excelling there. I mean, other people were shutting down, and the views through his 16, which is the Explore Scientific 16, they're absolutely amazing. I was blown away it's like a Zambudo mirror almost. I mean, it's that good. It's mind blowing. This picture I was working on, he was so nice to send me a cell phone snapshot of Saturn through a 9 1/4 telescope. And I want to give him the credit because it gave me a great point. It was monochromatic, of course. So I had to take it to the next level. So I gave it some color. And this is what it's looking like now. And eventually the rings are going to rotate. Next year, you won't see them. You'll just see a line across there, which is really incredible thing to see. So, even a small scope will show you the rings, like an 80 millimeter, to a 90, somewhere in there. You could see it with good optics and some magnification. Now, right now, some guys on cloudy nights were drawing Saturn, and they showed that the transits were on the top of the globe. So you could see the planets, Titan, Shadow, and a couple others, 3 dots on top of the planet. It's just incredible to see that. And, if you're out exploring it and looking at it, you're going to see it. And that's the beauty, is you got to get out, the more you look, the more you see. So these are all new ones from the 30-inch that I was able to view last year through the few star parties I did, which was very few compared to usual. But I really had to, drive to Arizona to get that scope. And that took some time and took a few days. So I was really saving myself for the trip. This is NGC 40, the planetary nebula. That actually, it looks colorful, like a bluish pink almost. Red, maybe. You can see, depending on how you see red, and you do need some aperture, but it's an incredible planetary nebula, the structure. NGC 40. Now, this was amazing. I have to tell you, we were looking at the Saturn Nebula. That's what this is. NGC 7009. Okay. And when I put the power, and I was running over 1,000 power on this thing, and there was another sketcher from Cloudy Nights, Andrew, and he was blown away because we were seeing the inner details of the structure of this planetary nebula. And then outside, you could see the actual exploded material around it, being illuminated, like a fluorescent light. It's getting ionized from the energy from that. So the gas is glowing in this eerie green. And the little tendrils on the sides, that's why they call it the Saturn Nebula, because every planetary nebula is different. When they explode, they create a different shape. And that's what's so unique about these stars. And, exploring the different types of shapes and looks of these, some of them that Hubble took, the Eye of God and the hourglass. I mean, incredible detail, spirographic and structure, symmetry in there that you don't see. But if you get those good nights where the seeing's incredible, transparency, everything aligns, you see stuff you've never seen before. This was one of those views. I mean, it was incredible. So this is actually a sketch from a sketch. I was trying to depict exactly how it looked. Kind of got it. I don't know. Look at the star in the middle. It was like an eerie greenish white. This one is a one I've painted many times. This is the blue snowball, NGC 7662. What's nice in the big scope, again, you do see a bluish green color, but you also notice the star color, that red star. It's always so noticeable right next to, the blue snowball. And I think that's an Andromeda. I tried a little new technique. You see the little lines emanating out. It just gives it that blast effect. The streamers of material that blew out from this thing, and the internal structure, that ring was so pronounced, and you could see the central star. Now on this planetary, it's usually much fainter. Most scopes you will not see that central star. It's shrouded in a lot of gas in front of it. Also, it's super small and faint in comparison to the nebula. So you really need a good night to get that. Of course, clusters, M13. You can't go wrong with the big dot. You work your way out. With solar system, you can start, early on if the moon's up and it's getting ready to set, and then you can work your way from the solar system outward, clusters, nebulas, all kinds of different stars, and there's many different objects to look at along the way. This was a Galaxy M63. This was the new sketch through the 30. Again, I was starting to see a little bit of a structure and a dust lane, but you have to look at these a long time, and they're very faint. I don't think we're Bortle 1 or even Bortle 2 there at Pinos, maybe Bortle 3. M106, that was incredible to see. A lot of these galaxies are real far away. Now, the next set is the comets. I'm getting ready to wrap this up. I know I'm running a little long. I wanted to do a lot more, but I had to delete a lot of pictures because of the time limit. Anyway, this was the first night I looked. They said, "Oh no, you can't see the comet." And so he said, "John, you got to get out now." I go out. Oh my gosh. When you see the tail on that comet on the 11th of October, that tail, it was very low in the sky, in between Venus and Arcturus. The tail literally was like 20 degrees, the nucleus from setting, maybe 30, and then the tail went almost all the way to zenith. And I think it was magnitude 0. So this is the initial black and white rough. I've looked at it through binoculars. I've looked at it through several different types of big Newtonian. I've looked at it through the refractor. And I have to say, Scott, that refractor, I don't know why for comets, the refractor seems like maybe the best tool to do it.
Oh, maybe.
To explore the wide
Lower
range
power, but lots of
yeah.
contrast. Yeah.
And then you go in with the 9mm 120, You want your mind blown. I'm going to tell you right now, that eyepiece has shown me a couple views I've never been able to repeat. It's just an incredible eyepiece.
Yeah.
You know, I probably couldn't repeat it again because every night the comet got dimmer and dimmer and dimmer.
Yeah.
Here it is in color, so I made a color version.
Nice.
There's another night. I mean, I literally did it every night. I would make time because it's early in the evening. It's not past my bedtime, 8 o'clock.
8 o'clock.
Well, when I live my normal life, I work on those hours. When I become an astronomer,
Yeah.
I probably take years off of my life because I stay up for days. I refuse to, and then in the daytime you can't sleep because you're energized. All the photons and the people in the hobby talking about the views we had, and you know, we always talk about how do you think that formed like that, or that it was able to, you know, do what it does when you look, and you know, it's just incredible stuff. We always just discuss what we see, and we have a group of people. It's really fun to do. And some of the lists that you get in objects, you know, there's so many things. Even today, I'm still looking at stuff I've never seen before. So one of the nights, I think this was with the 12.5. So I had them both out, the 12.5 Zambuto Portaball tracking. And I was able to get in a little on the core and get some of the detail. You know, on the front of the comet, there was some weird stuff going on. Little streamers coming out, and even on the side, you know, you have the ion tail and the gas tail, but there was another tail that would form because bits of material were breaking off of the nucleus, and it was like Shoemaker-Levy 9. When you see the comet beads lining up, the fragments, this had similar fragments, but they were broken off, and they were emitting a greenish glow that I could clearly see in the eyepiece, and it had little points of light, which were chunks. And this only lasted for a couple, maybe an hour, you know, while I viewed it. And you don't have that much time to watch it because it sets before and it gets too low. But that was incredible. This was later, much later, when you would not even think to look at the comet. But if you were, you know, had the will and a scope and you were ready to get out there and do it, you could see it again. And it's still impressive even today. I think it's in Aquila right now. I'm not sure.
Yeah, David Levy was looking at it just recently.
So
he said he saw an outburst.
This is the instrument of choice for my surgical and solar, lunar, comet, and planetary work. This is an incredible scope. I mean, I have some very elegant scopes, and they won't show me that, you know, field. I can't see the true essence of that object because I'm too zoomed in. So this is a 6-inch triplet carbon fiber. This is the one you got me, Scott. And I got to tell you, it's a masterpiece.
Great.
So through the whole thing, when I was looking at the comet, this was the best view through this telescope, believe it or not. With the one, I used the 120. I used a wide range of eyepieces, Teleview and Explore Scientific mostly, even the Nikon Nav. But you know, it's more about the optics and the quality of the build and the ease of use. It's a great scope. So here it is. This is my baby right here. The next one. Of course, that's the carbon fiber shine. You know, I put probably 30 coats of carnauba on there because I really don't want to harm the finish on this thing. It's absolutely gorgeous. And there it is. And this was the comet. I would say it was midway through, probably 3 or 4 days after, maybe 15th or 16th. But it was amazing, the view I was getting. Look at the detail in the core. And you can see that the one on the left where the material was coming out. And then it also had like literally looked like a headlight. Now I don't know what that is. If anybody could explain that, how does it shoot a beam like straight out? I've never, I don't
Well,
understand.
the comet had an anti-tail, which was pretty visible and certainly showed up in photographs quite easily.
I was
But,
getting hints of it.
yeah,
I mean, it was very clear here.
yeah, because the tail is just kind of wrapped around, and we're seeing it from the other side of its, kind of a curled orbit, so
I could see
it was
like the
cool to see.
gas coming
Yeah,
out of it, the
yeah,
releasing the oxygen and the moisture,
yeah.
and in those chunks. I couldn't believe I could actually see. It's like when you look at a solar flare, they don't change before your eyes, but this thing definitely started to change over an hour's period,
That's
and
cool.
then it was gone.
Yeah, that's very cool.
So I don't know if anybody else saw that or recorded that, but that was really cool, and I attribute that to the killer optics and good seeing.
A good astronomer,
Well,
you
I
have a
mean,
very trained eye too, John. So
it's tough to find this. I had looked at it so long. I mean, I literally, once I saw it, I was blown away. I was just there until it set. Boss was right there with me.
mhm.
And what was nice, I could just go inside, pick the scope up, put it in the shed. Still pretty heavy on a G11, but I'm okay. I still got a little left in me. So again, I always close with, a little flower. I didn't get many flower shots lately, but this is one I always liked.
Very nice.
Just amazing. And if you have a microscope, you can explore even further in. And I would like to say happy Thanksgiving to everybody from my friends out in the solar system. They're on the moon. It's a little cold there, but they're underground. They're okay.
Yeah, all right. Yeah, I like the art they have hanging on the wall there. So
Well, they're very fond of cubism and modern art as I created this picture. So this is what I'm going to send all my friends and family for Thanksgiving. This picture. You know what? They eat good over there. They don't eat turkeys, but that might be like an octopus or something. But exploration is critical, and every human on this planet has an explorer inside. You look all the expeditions, Everest and in Antarctica, even the oceans, finding new lands, and eventually you have to go outward. There's still a lot of exploration left here on the planet. There's caves, underground stuff, and in the ocean, the least explored place of all. So I think we're blessed to have the technologies we do today and the abilities to share knowledge and data and major breakthroughs. And eventually you learn so much about everything that you have to go outward to find new stuff. And, that's the obvious thing, right? I mean, that's why we're exploring space.
yeah.
To get on the moon, you could actually have a telescope on the dark side, or you could have a platform to launch from where we could get most of the material we need from the moon and the water that they recently found. They have so much water on the moon that there's like lakes in those south craters. There's literally so many gallons of water there. A lot of them are trapped in those little beads that when they melt, there's water inside. The glass from the impacts, there's trapped water in there. Those are the elements. So I believe there's probably frozen life on the moon, microbiological from the Earth. I mean, if it came to the Earth through an asteroid or a comet, it could certainly go to another planet like Mars or the moon. who knows? Even like the moons of Jupiter, Saturn, they potentially could have life as well. You just don't know until you get the ability to get there and see it, you know. So right now it's robots and rovers and stuff like that because we can't handle the harshness of space and do those things like they can. So we've been very fortunate, I think, with our technology and all the things we have to explore with now. So get ready. All the new discoveries are coming. And I am waiting for confirmation, you know. And I don't think I'd want to go to M51 if, you know, they could take you somewhere, but maybe they could take you out and see Alpha Centauri. Let's see if there is life there, you know, on those planets that they have around the exoplanets. I mean, there's many possibilities, right? You never know. Anyway, that's my presentation. I appreciate everybody coming on tonight, and it's very good to be back. And I look forward to doing some more.
Yeah. And Harold Block is wishing you a happy Thanksgiving. So
happy Thanksgiving, everybody. Don't eat too much turkey. You know what happens. You get tired. Tryptophan.
Tired. Oh, yeah. That's right.
Yeah.
Is that Adrien? Did I hear an Adrien?
So,
Adrien.
Happy Thanksgiving, my old buddy John.
Yes, sir.
Yeah, I popped in because it's we're getting close to 10.
Yeah,
and,
I went over. I'm
I
sorry.
think there may be another presentation before me, but I'm returning. No, that's okay. It was great listening. And if I took the opportunity to peek at some of the images you had, and I loved what you were saying at the end about exploration. And in fact, I think you helped me with the segment that I want to do at the end, which will likely be more or less a quick discussion on just some things that I've seen when it comes to the spirit of exploration versus some of the things that we've had to deal with, starting from the pandemic 2020 and just some tendencies that I'm seeing, and just wanted to quickly discuss those and talk about the merits of exploration versus preservation, which is I'm seeing a lot of preservation and not wanting to take these giant steps, especially on social media outlets. But I'll figure that out while the next presentation goes on, because I think we've got a good one that we've been waiting on for planet Jupiter.
Yeah, that's right.
Yes.
Yeah,
well, thank
Carlos.
you again. And I apologize for going
good to
over.
See you.
I could have went for another hour, but
you know what, John, you have too much energy and love for this. You're not gonna. You stop when you're ready. And,
the love is always
we
there
can all feel
because this is this hobby. It's all about love. I mean, who doesn't love this hobby and the companionship and just the camaraderie when you're there? I mean, you don't even really need to look at stars. You can just be happy talking about, all the stuff you've discovered in your experiences, and, look at your workload. Man, it doesn't happen easy. You really have to figure this stuff out to get it to the level that you have. And it's a lot of time and dedication.
Yeah, it takes time.
Yep. Okay, I'm going to close with that.
Too.
Let's get started with
thank you
with our next speaker. Thanks very much, John, and have a good night. And if
thank you so much. Look forward to seeing you.
Happy Thanksgiving. Yeah.
Keep looking up. Always.
That's right. Our next speaker is Carlos Hernandez. He's a renowned planetary expert, space artist, and he's celebrated for his detailed astronomical sketches and deep knowledge of the solar system. I think that some of the images that I've seen from Carlos with his unique perspective of spacecraft missions, views of, moons around the planets. His images and sketches that he sends me are often very much timed with what's currently going on. So something will be in the news about space exploration or something that they found on another planet, and Carlos will be right there with a illustration or his digital paintings that he does. And so here he's going to share with us his knowledge about Jupiter. You're going to be learning some stuff from a true master of planetary observations. So let me bring this on, and here we go from Carlos.
Hello, my name is Carlos Hernandez, and I have been invited by Scott Roberts and Explore Scientific to present a lecture on observing the planet Jupiter. As we all know, Jupiter is the largest planet in the solar system and is referred to as the king of the planets. Jupiter is, in mythology, the king of the gods. Jupiter is the Roman name for the king of the gods, and in Greek, it is Zeus. And he was the ruler of all the gods, and he had a powerful lightning bolt that he used to eliminate a lot of his enemies at the time in mythology. Jupiter is the largest planet, as I said a moment ago. It is the 5th planet from the sun. It orbits at an average distance of approximately 484 million miles or 778 million kilometers, which in astronomical units, which is equal to 93 million miles or 150 million kilometers. That's one astronomical unit. Jupiter is located at approximately 5.2 astronomical units from the sun. It orbits the sun in a period of approximately 12 years, exactly 11.9 years, and therefore it is located within each zodiacal constellation yearly, as its orbit coincides with the number of zodiacal constellations. Jupiter is made up mostly of hydrogen, 90%, and helium, 10%, and trace elements including ammonia, methane, and very little water vapor, and hydrocarbons including ethane and benzene. Here we see a slide showing the comparison of Jupiter on the left and the Earth on the right. You could fit almost 12 Earths across the equator of the planet Jupiter. If you could hollow out Jupiter like a pumpkin, you could fit over 1,300 Earths inside of it. As you can see, when you look at Jupiter in a telescope, you will notice light zones and dark belts across the disk of the planet. And these belts and zones have different names according to their position over the globe of the planet Jupiter. On top, we see the North Polar region, and then we see a succession of interposing belts and zones. And you start with the North Equatorial Belt right above the equator. And you go up, and there's the North Tropical Zone, the North Temperate Belt, the North Temperate Zone. Now, when you go above the North Temperate Zone and you see belts and zones, then you add another north or south nomenclature to it. So the next belt would be the north-north temperate belt or the north-north temperate zone. And this continues all the way up to the north or south polar regions of the planet. Jupiter has intense winds or jets that are located throughout the planet, and the greatest winds or jets are located over the equatorial zone of the planet, and as well as the north tropical zone. Then as you go north or south, the winds decrease in velocity. Now, the winds also are located towards the east, which is considered prograde direction, and the winds that go westward are considered retrograde. And they can get up to 500 miles an hour. This is the diagram that I produced showing the different layers of Jupiter's upper atmosphere, the skin of the planet, showing the thermosphere at the top. Right below is the stratosphere, then the troposphere. Now, most of the clouds that we see when we look at Jupiter through the telescope are located within the troposphere, and that contains mostly ammonia ice clouds, but also ammonium hydrosulfide and other compounds that give the different colors to the clouds and belts of the planet. As you go in towards the core, the center of Jupiter, the pressures as noted on the right and the altitude on the left increases. So the lower you go into the planet, the temperature and the pressures increase to the point that at about 10 bars or 100 kilometers below the what's considered the 0 point or surface of the planet is at the point at which you have a pressure of 1 bar. 100 kilometers below that is where the gases become a liquid form. They transition into a liquid form at approximately this altitude in the atmosphere of the planet. As I mentioned, the zones and belts are noticed when you observe the planet. These zones are consisting mostly of ammonia ice clouds that are higher in elevation and cooler in temperature, whereas the zones are devoid of mostly of ammonia ice clouds and are lower in altitude, but are warmer in temperature. So the zones, the air rises, and in the belts, the cool air sinks. At times, you have different eruptions over different parts of the planet, and a well-known eruption occurs over the south equatorial belt. As you can see in the section of a excellently detailed image by a friend, Christopher Go, you can see the development of a south equatorial belt disturbance, an SEB disturbance. And this occurs periodically, and it starts off as either a white or dark spot that continues to expand over a period of days to weeks until it encircles the entire belt. And below is a painting that I produced showing if you were located directly above that white spot erupting from below the atmosphere of the planet, you could see the main area to the right, and then the leading cloud to the left. Here is a drawing of a south equatorial belt disturbance that I made on March 19, 2019, using my instrument, a 9-inch Maxitov Cassegrain. And you can see the different parts of the disturbance. You can see as it appears in white clumps within dark areas between them. And this is considered a south equatorial belt or SEB disturbance. In 1995, NASA sent a probe into the atmosphere of Jupiter called Galileo. It went along with the Galileo orbiter that was orbiting Jupiter. And this is the first time that we were able to explore the atmosphere of a gas giant planet, in this case, Jupiter. And it went into the entry point was located over the equator of the planet, and it descended into the planet. And as it descended, it took measurements of the different gases and temperatures of the planet as it descended. It transmitted data to the orbiter above for approximately 57 minutes before it was destroyed by the extremely high temperatures and pressures within the atmosphere of the planet. And that occurred on December 7th, 1995. A diagram showing the entry and descent of the Galileo atmospheric probe on December 7th, 1995. And it continued to transmit information all the way down to 140 kilometers below the 0 point of the atmosphere, or a pressure of 24 bars. The Great Red Spot is well known to most amateur astronomers, and it is an elongated anticyclonic vortex located over the southern hemisphere of the planet, and it measures approximately 1,300 kilometers in width and several hundred kilometers in height. Now, this is a cyclone or an anticyclonic vortex that has definitely been documented and observed and recorded since the late 1870s. Now, it may have been visible to astronomers as early as the mid-1600s, but we know for sure that it's been around since the 1870s. And it has a period, it rotates in a period of approximately 6 days, and the height of the top of the Great Red Spot is approximately 5 miles above the cloud tops, or 8 kilometers. But recent studies by the Juno orbiting spacecraft show that it extends as far as 500 kilometers below the top of the Great Red Spot into the atmosphere of the planet. A painting that I did of what it would look like if you were above the top of the atmosphere, adjacent to the Great Red Spot, and this is what you may witness if you were an astronaut floating within the atmosphere of the planet. Now, what we see when we observe the planet is the very outer skin of the planet. And that accounts for the zones and the belts. But as I mentioned earlier, as you descend into the planet, the gases become liquid. And as you descend, you encounter what's called metallic hydrogen, which occurs at extremely high pressures and temperatures. And this occurs all the way down until you get to the core of the planet, which is about 10 to 20 Earth masses in size. And that is the insides of Jupiter, and Saturn, Uranus, and Neptune are somewhat similar to this interior as well. Jupiter also has very faint rings that are not typically visible to the amateur or professionals from the Earth unless they image the planet in infrared wavelengths. But the Voyager spacecraft, when it flew by the planet in 1979 and 1980, it imaged these faint rings surrounding the planet. And Saturn, as we all know, with the beautiful ring system, but Uranus and Neptune also has a faint ring system as well. Jupiter has a total of 95 satellites or moons, and the largest of these are called the Galilean satellites, named after the discoverer Galileo Galilei, when he discovered them orbiting the planet with his primitive refractor telescope on January 7th, 1610. And you've got Io on the left, extreme left, followed by Europa, then Ganymede and Callisto. Io is a fascinating satellite, and it's the closest of the Galilean satellites, and it has over 400 active volcanoes over its surface. And here's a painting that I did of what it would look like if you were able to stand over the surface of the planet with a sulfur volcano erupting and the lava lake below. And the reason that it is so volcanically active is that as it orbits Jupiter, the inside is stressed by tidal forces that heats the interior of the satellite, producing this molten lava, which then erupts onto the surface of the moon. The next satellite is a fascinating one called Europa. And we've heard a lot about Europa, that there's a possibility of a subsurface ocean, and who knows what possible life forms, if any, are present. But we are hoping to study this interesting satellite with the NASA Europa Clipper, which was recently launched and will arrive at Jupiter in 2030, followed by the European Space Agency's JUICE spacecraft, which will also study Europa, but also Ganymede and Callisto. And this is a painting I did showing the eruption of a geyser over the surface of the planet, with Jupiter visible in the background. The largest satellite of Jupiter and the largest satellite in the solar system is Ganymede, and is actually larger than the planet Mercury. So you've got a moon orbiting a planet that's actually larger than another planet. And it is also a very interesting planet that you see groove and craters and other interesting surface features. And it too may have a subsurface ocean that will be studied by the ESA JUICE spacecraft in the near future. And it has aurora that visible over its poles, as well as you can see that the planet Jupiter has incredible aurora as well.
What medium
This
is
is my
this?
painting of the surface of Callisto, the outermost of the Galilean satellites, that is a very heavily cratered moon. And this is one of the surfaces area within one of the craters of the moon Callisto, and with Jupiter visible in the distance over the horizon. Jupiter will arrive at opposition on December 7th, 2024, and will be located within the constellation of Taurus, the Bull. And it will form a bright star in the core, in the center of Taurus, and it should be a spectacular sight in many telescopes. The tools that we use to observe Jupiter include instruments such as a refractor that uses the lens and a reflector that uses a mirror to form their images. These are two examples of the Explore Scientific refractor, an apochromat, or you can use a triplet, also more expensive but less color, better color correction. And the reflector, this is a Newtonian reflector that uses a parabolic primary mirror and a secondary flat mirror to produce the image. Other instrument designs used to study the planets, including Jupiter, include the Schmidt-Cassegrain telescope on the left. That's my Celestron 8-inch that I actually obtained in 1976 and have used it well on the planets and deep sky objects, and it produces excellent images. The one on the right is my current instrument. It's a 9-inch Max Hutov Cassegrain that employs both a corrector in the front and mirrors inside. The primary large one in the back, and then a smaller secondary over the corrector plate that reflects the images to the back of the instrument where you observe. Different eyepiece designs are very useful for observing the planets, including the Abbe orthoscopic at the top that uses 4 elements, and the popular colossal eyepiece in the middle that also uses 4 elements. And another well-known eyepiece for planetary observation is the Brandon eyepiece at the bottom that uses 4 elements as well. For my own observations, I like to use high-resolution eyepieces, and the advantage that I prefer using the Explore Scientific eyepieces is that they are also waterproof, besides being of high quality, producing sharp contrast images that allow me to see most of the detail on the planets. Useful accessories for observing Jupiter and the other planets and moon are the color filters. Now, using the different colors, you are able to pick out subtle features over the planet. The red filter might show you some dark condensations and the belts slightly better, as well as the orange filter. The yellow filter can be used to bring out bright features and some dark features. The green is good to show dark objects, including the belts and condensations. The blue and the violet are useful for the belts as well. Of all these, the ones that'll bring out the belts and the zones typically the best are the blue and the blue-green filters for observing Jupiter.
No polarizer?
We are at the mercy of the atmosphere on Earth, which is a blessing that it provides air for us, but it also is a blanket that waves at times because of the difference in temperatures. And we are affected, the images are affected by turbulence within the atmosphere. And this is a scale used to grade the seeing or the turbulence in the atmosphere that was developed by a Harvard astronomer, William H. Pickering. It's called the Pickering Seeing Scale, and it's from 0 or 1, which is the absolute worst, to 10, the absolute perfect steady image. Another scale was produced by the French Greco astronomer Eugene Antonati, and this uses a scale from 1 to 5, with 1 being a perfect image, 2 less perfect, 3 average, 4 poor, and 5 extremely turbulent and pretty useless to make an observation. Now you can use forms But you can produce your own or obtain from different organizations, including the Association of Lunar and Planetary Observers, ALPO, the British Astronomical Association, and the Oriental Astronomical Association as well, in order to produce a drawing of what you see, what you observe at the telescope. And this is an example of an observation of Jupiter that I made on March 3rd, 2004, using my 9-inch Maksutov Cassegrain at 257x, showing a wealth of detail over the planet. And this was made under very good seeing conditions, and 8 out of 10, or 2 on the Antonelli scale. And you can see the great red spot located over the central meridian in the southern hemisphere, as the telescope flips the image with south at the top and north at the bottom. And you can see the south equatorial belt, north equatorial belt, and the different polar regions and other interesting features, including white ovals and dark condensations or spots. The image immediately to the right of the drawing is what's called an intensity estimate. And what you're doing there is using a scale from 0 to 10, where 0 is black and 10 is the perfect white. And here I've graded the different features that were visible according to how dark I perceived them over the planet at the time. Below that intensity estimate drawing is a sectional sketch that I focused specifically on the Great Red Spot region to show the wealth of detail that I was noting over the Great Red Spot and surrounding region at the time. And below it is numbers indicating the different longitudes. And Jupiter has 3 longitude systems. It's not a solid object, it's a gaseous planet. So the midsection, the equatorial zone from 7 degrees north or 7 degrees south, is called System 1, and that rotates in a period of 9 hours, 50 minutes, 30 seconds. And the regions north and south of the equatorial zone are called System 2, that rotate in a period of 9 hours, 55 minutes, and 45 seconds. The third system is called L3, and that's the rotation of the core of the planet, and that's considered the true rotation period, which is similar to the System 2, but different by a couple of seconds. A drawing of Jupiter that I made on November 11th, 2001, using an 8-inch Plezov Cassegrain that produced an excellent image showing the Great Red Spot, some blue festoons of the equatorial zone, and the north and south equatorial belts and polar regions of the planet at the time. You can also make a sectional sketch of the planet instead of making a full disk drawing, as Jupiter tends to get complicated at times because of the wealth of detail that you can see over the planet. So you don't actually have to make an entire disk drawing. You can do what's called a sectional sketch, and that's what I've done here, showing detail within the north equatorial belt on the planet on March 19, 2017. Sometimes if the seeing is adequately still, adequately well stabilized, you may be able to detect detail over the largest satellites of Jupiter. And this is a drawing that I made of detail that I noted over Ganymede on October 2nd, 2010. And the image on the right is a corresponding simulation using the NASA Solar System Simulator. And you can see very similar albedo bright and dark features over the moon that correspond with the simulator. So I wasn't able to resolve the detail that you would see with a spacecraft, but I could see that there was differences in brightness and darkness over the disk of the moon. Now, in 1994, mankind was treated to a show of cometary impacts over the southern hemisphere of the planet Jupiter, produced by the breakup of a comet that was once orbiting the planet called Shoemaker-Levy 9. And over a period of nearly a week, 23 fragments from the comet impacted the southern region of the planet and producing huge explosions that extended into the space above Jupiter. And the remnant of the debris, the scars of these impacts, was visible to astronomers for weeks and months afterwards. A painting that I did of the eruption, the explosion, after an impact of one of the cometary fragments, if you're able to be in a spacecraft floating above the cloud top layers at the time. I was able to observe the impacts with my friends shown in this image, with Tibi Dioria next to his telescope and Jeff Bache, which was the owner and producer of that telescope as well, a 16-inch f7 Newtonian that produced excellent images and allowed us to see a lot of the impact sites over a period of a week in July of 1994. These are drawings that I made, sectional sketches of the southern hemisphere and the impact sites produced by the comet fragments over that 7-day period in July of 1994. And if you observe the impact sites over a period of weeks, you would note the evolution or the spreading out of the material from the impacts, and it produced different shapes, and it was very interesting. Now, we have a spacecraft at this time orbiting Jupiter, obtaining measurements of the planet, and this is the Juno spacecraft orbiting the polar region, and you can see a spectacular aurora over the polar region while it's flying overhead. This is a painting that I produced of what it would look like if you were above the spacecraft orbiting the polar region at the time. As I mentioned earlier, the NASA is sending a spacecraft called the Europa Clipper that will be orbiting Jupiter, but it's going to be making close flybys of the moon Europa in order to determine that if it does have a subsurface ocean, how extensive the ocean is and other characteristics of this fascinating moon that theoretically, but not proven, could harbor some form of life, a very basic life, but this is something that needs to be further evaluated, and that's why we're sending these spacecraft to explore this and other Galilean moons. And with that, I finished my lecture, and if you have any questions, please contact Scott Roberts at Explore Scientific, and I will be happy to answer whatever questions I may be addressed. Have a good evening. Thank you.
Scott, I think you're on mute.
That's right. Carlos, I wanted to thank you for putting together that pre-recorded presentation, and I think that you were out there in the audience watching it. So very good job, excellent work, and lots of great information about Jupiter. Next up is Adrien Bradley. Adrien is he's of course a regular on the Global Star Party, and he's an acclaimed night sky photographer and just a great photographer, landscape photographer as well. He occasionally shows me images of wildlife like birds and stuff like that that he takes. But he has a great eye. He's very tuned to very balanced perspective on what draws you into an image, the
Visionary.
composition of that image, and so just a few moments of staring into one of his landscapes that he shoots on the Upper Peninsula with the Milky Way in the background will spell out everything that you need to know about Adrien Bradley's talent. So, Adrien, thanks for coming on to Global Star Party, and I guess you just bowled a
Yeah, just bold. That's why you see me with a bowling league shirt on. But
Okay.
yeah, and I've got my name in case anyone forgot.
Forgets.
Name's Adrian. But yeah, so yeah, we're talking about the Upper Peninsula of Michigan. So
Yeah.
one of the things I wanted to do, because I know we're getting late and I wanted to close down our Global Star Party by talking about, we were talking about exploration in this whole Global Star Party. And I'll go ahead and share, as always, my second desktop here. Let me share that. And you should see. So Scott brought me in talking about what it's like to see the Milky Way. When I took this photo, and I've shared this photo on Global Star Party a number of times. If you haven't been to Global Star Party to see any work, you're going to notice some of it's similar to my buddy John and what he showed during his presentation. But the Milky Way itself is there for everyone to see and to explore. And things like if I click on this and see if I can zoom in, one of the articles that will be coming out in Astronomy magazine soon, the February issue, I've got something where I wrote an article on the treasures of the Milky Way, and that's what this is. And I wrote about little things like this little dark nebula Barnard Z here. These two, I wrote about these two clusters, open clusters, seeing them in binoculars. And what I learned is the darker your sky, the more that these pop out. If you're not in a very dark sky, you don't actually see these naked eye when you see the Milky Way. A lot of what you're seeing in here was naked eye. It was a really good night, and it was naked eye when I was out at in the Upper Peninsula. Up until seeing this, that was my it was sort of the revelation, like, wow, it can get that good. Until I went to a darker location. Other thing that I like to do is challenge norms. Milky Way photography was typically the kind that you see where it's dark, and now the foreground is usually a lot more interesting than this. This is just kind of a barren wasteland in the middle of a giant national forest, and the sky just opened up. This is it's another similar rendering of that. But if you go now, you can see where I went and what I was attempting to do. Clouds came in. You're going to see a lot of photos that that I took after that, partial eclipses. This is a picture that's after John Schwartz's own heart.
Love
It's
that.
covered with, you've drawn this a few times.
Yeah.
You'll see some of the getting images of these pictures is much harder than to draw them. And John does a good job of that. But keeping with the theme of exploration, all of these pictures that you see, I decided to go out. This is 3 hours from where I live, and I decided to go out and take these photos largely because I just wanted to see what I could create with that. And as you can see here, I'm shooting right at the sun. It's low on the horizon, and I'm shooting right at it. Now, I think there was smoke in the air at the time of this particular sunset, but shooting right at the sun. There's always the don't look at the sun directly. We do recommend that, but if you do this enough times, there are some times where you can go ahead and take a picture of the sun. You just have to know you got cloud cover, you have low on the horizon about to set. Those are some times that you can shoot right at the sun.
That one looks beautiful.
Which one?
The Milky Way in the setting sun. That's incredible.
Let's see.
I think that one.
So I don't think it's a setting sun.
But it's set already.
Yeah, unfortunately,
a
lot of misconception about this, and I think I do have. I'm trying to think if I do have it. I do have a Milky Way in a setting sun, but the sun's not in the picture. But it's in the middle of sun. It's like it's
not
nautical twilight.
Right.
There are only certain places you can see it. This is glow from a distant town.
No.
It looks like sunset. Glow from a distant town, and then you got a meteor here. If you do this enough, you capture meteors all the time. And I leave that color in. I used to mask it out, but I leave it in because I want the images to show, just what type of light is going on. Whatever I capture, I want it to be present. And in this particular case, you have a chance, bolt of lightning from a distant thunderhead here and a meteor screaming over. Yep, right over the center. And I've got a couple of times where I've had a meteor, photobomb some images. And, with my photography, the exploration side wants to get images that aren't often always sought after. Like when the moon is up and you've got kind of the whole scene is kind of this bluish thing where you've got some stars here and you've got the moon and you've got it in a way you try and process it so that it looks the way that your eye saw it. Now there may be a bit more blue in this image than normal, but you keep trying, you keep trying and you keep pushing. Here's the sunset in the Milky Way image, John. This is one where the sun is behind. Everything's brightened a little bit. The sun is behind the mesa and down. This is nautical twilight. Starlight's just coming out. There's still some clouds. Milky Way is here.
Right.
Cloudy skies you can explore and try and take images. One thing I was going to discuss and using some of these images as a backdrop, such as going here and seeing this Orion side of the Milky Way and the zodiacal light. That's just not something you see every day east of the Mississippi. You can detect it, you can see it, but you need an exceptional night out in the western part of the United States. It's it's a little bit easier to get this sort of image. I had put together some notes on coming to a star party like this. and being able to take images like this. And, just um, lately, someone posted to the Okie site that they weren't going to come anymore because they had captured a virus while they were out here, and they didn't want to, they had such a bad experience going home and not being able to go in. They considered it, viruses just running rampant, and just didn't, the experience, it wasn't enough for him to see these dark skies or, observe. In he decided he'd had enough of the big star parties because of the propensity to catch disease. And we're in an era now where, since 2020, we're faced with making decisions of, do I isolate, shelter in place because I don't want to capture a disease that could be life threatening to me, or do I go out there and we're going to skim through a lot of these. Do I go out there and look for some of these, whether the skies are dark or not so dark at all, such as this image, same image of Orion in the winter Milky Way, as taken from a less darker site, but it is in Michigan. And, with certain technique, you can still get, this is over the lake, you can still get some of the same things, just not quite as much detail. The darker your skies, the better. And these are older images. This is one I really, really like because it was stacked and it was over this beautiful lake. And I still want to improve a bit on it. But you come down to having to make decisions. Here's your bird picture, by the way, Scott. There you go. Heron in the light.
Very nice.
Decisions to come out. A lot of these I went out on my own, and others here I'm in Vegas, but a lot of these images I'm out on my own. I'm I'm choosing to go out. Some of these images I'm out with others, or out my priest who has since passed away. He was with us.
Oh, how nice.
And we took this picture. This was his car. This was his old cabin. There's there's a cross that now sits in front of my house. It used to sit right here. And what I did is I tried to capture the rising Milky Way through that gap right over the cabin. And it sits on that same lake. Someone else now owns it and has changed it around. But this was
It's a beautiful shot, Adrien.
Yeah, it was a moment in time when
Wow, that really has a feel.
he was with us. Yep, it's
warm.
Cabin in the it's a lower peninsula, but it's in a beautiful area, not far from this area here, this sort of beach area. So, and in more upper peninsula, Aurora. So bringing it back, coming out by yourself to see this is nice, but is it nicer to share with others? And in the world we're living in, we're being challenged to face. There's many who may love astronomy, but they're facing challenges to their health, and you want to be able to, you want to preserve your health. You want to, you don't want to get sick, and you make you decide that, well, being around people is how you get sick. So, what do we do? It becomes it becomes a tougher choice now than it used to be before 2020. You just came out and you went to the doctor. If you got sick, you got your antibiotics, and you fought off whatever you had. Now there's just it feels like there's a greater concern for, do you want to go to these parties at all? And, it's sort of a greater disdain for being sick in general. And, having someone post that they don't want to come out to the Okie Star party anymore. this becomes
I think
your
that's
astronomy
quite an
life. And
anomaly.
you can see this image in the June issue 2024 of Astronomy magazine, me looking at the Milky Way by myself. I've gone out on my own, and I don't think I was on my own when I took this. I was with a coworker who happened to be out there, and while I'm taking these images, she was from China, and she talked about the Cygnus rift. I don't think I took a picture of it at the time, but she talked about the kind of the difference in the stories from China versus the US on what the Cygnus rift, which would be way up there. The you had two lovers on a cross the river. She says that the man was too lazy to build the bridge and only wanted to see the woman until, when the bridge was being built by the swan. So they cast a side eye on the male figure in that in that story, and I found that pretty interesting. But here you have another of my attempts at capturing what it's like to be at a star party. There are a lot of people, there's a lot of telescopes, there's an imager right here. It's, to me, this is a beautiful scene, but you've got folks willing to give up that sort of scene and strike out on their own because we're more concerned about disease. So I think and I've tried to do this image every single time I go back, and we can capture different parts of the Milky Way. I've tried this scene again and again, and then I come home to this. It's not as dark, but you can still make things beautiful if you figure out how to do that. And so I guess what I'm saying here through recycling, I recycle a lot of images. I haven't been able to take new ones. I'm gonna slowly scroll through these. We'll stop at a couple of ones that I've loved, but I haven't really done much with. But your typical panorama, these are nice images to get if you're, to kind of you want to create a beautiful image. You put the elements together. You can get them in 30 seconds if it's dark enough. Even if you have an image like this,
Wow.
This is a challenge. Get the moon's very bright. What kind of image can you get if you take a picture? This is where I stopped. There's
No filter?
no filters.
Oh man, you're gotta
I generally don't shoot with filters. I'll do some things in post, like masking. I use masking rather than filters to lower, if I want to lower some of the light, or I'll lower some exposure and sliders.
yeah,
Select.
that helps bring out the
Yeah.
contrast and
Yep.
dim the light.
Yep, that's what I do. And so even if the moon is out in the daytime, I see what kind of images I can get with panoramas. There you have the moon. My goal was always shoot what I see. And so sometimes I don't try and isolate the moon. I just take a quick photo because the scene looks pretty, it looks pretty to me. And, that's essentially a shoot what I see photo.
That
Or
feels like
sometimes
Hawaii.
you don't see it. And I've shown this one before, Scott. You remember seeing this rainbow image here.
Oh yeah.
Yep. Nighttime rainbow
Is that a
caused by
moonbow or
that
a
moon, which turns out it was not a full moon. And then this, I don't know if I showed this one so much, me trying to get the Cygnus region, and you can kind of see where I used a mask and I ended up creating a line that didn't really exist in the sky there. Trying to see if I could get any semblance of Cygnus there. So So yeah, as we go through these photos, and you can see me trying a bunch of different things. There's the people. For me, I like being in this situation. I like being there's people around looking up. To me, there's three meteors. And this was a Perseus night, I believe. Or I forget what night. This was not a I don't think this was a Geminids night. There's Perseus, double clusters over here, and Perseus is here. So this is a Perseids night at an observing site here. This sort of thing to me is what makes astronomy worthwhile, sharing it with others, having people come out and see it and describing what you see in the night sky. It isn't just about the night sky itself. It's about being there, even if there isn't much to look at in the night sky. I'm aiming directly towards these stars that I'm pointing out are the stars of Ursa Major, the Big Dipper, the Plow. They just melt in there with the rest of these stars. There's so many when you take an image. That always blows me away that there's so many stars that you can pick up. And more bird pictures. I'm going to skim down to a couple more scenes, things you don't see up north or where I am, seeing the Milky Way tilt that far and still yet being able to see the core is a memorable experience. Seeing a storm and the Milky Way coming out is a
That
memorable
much
experience.
clouds back there. It's cloudy, huh? A lot of times.
It's cloudy. Well, when you got a major storm cell coming through with all this lightning, you got two things you normally don't see together. And even when it's cloudy, I'm still trying to take some images here. And in Denver. And then we're going to scroll through to
That's funny.
this
It
event.
looks like I'm looking at my own work.
Yeah, most of us got the same type of images. And then I went ahead and tried and get kind of a wide angle view what the sky looks like.
That's a killer one.
Even in an image like this, you're working on things. This was a poor comp. This is look at all the stars in the sky. This was an exceptional night. There was a lot of haze, and there was actually some aurora there. There's my buddy working, and there's some aurora behind those trees.
Yeah.
In this field. Now, you might look at that and say, that's a beautiful image. Then this happened.
Whoa.
So one other thing that I was concerned about is if you go to social media, we had a lot of auroral outbursts and they got as far south. I think all of us, those of us still watching, may have seen aurora. This is up close. The auroral curtain is over your head when you see it like this. Most of you, we've seen aurora, even if it's blazing and it's going, but it's in a distance. Pardon the dust bunnies here in the image, but you see these curtains, and you see those curtains a lot. Folks go to Norway or whatever.
Amazing.
Yeah,
My
you're
God.
looking up above and you see it, and so people will question and they'll say, "Is this real?" They'll go to social media, and somehow they decide that, well, you're only supposed to see something like this in an Arctic area like Norway, Iceland, or whatever.
You're north. You're way north.
Well, this was a little further south. This was in Canada, but it's an area further south on Lake Huron. Yes, we're up north. I actually like this because you have the photographer taking the photos as the aurora's going on. this was one of the outbursts of aurora that we had. It was beautiful. Um, and you have folks that are like, well, someone's putting up projectors because it's only supposed to happen. This is only supposed to happen in certain places to the north. And I would just say, don't believe a lot of what's being said on social media. Exploration is what leads us to be able to see. If we didn't get in those cars that night and drive out here, we wouldn't have seen any of these lights. And this was one of the biggest displays I'd ever seen. It basically blew me. Here's a panorama of the whole thing.
Those were huge flares that set those off. We even had them
Yeah,
here.
you remember it, John. It
Yeah,
was May
I
10th.
do.
Yeah, this is, and it was seen. It was a beautiful event to watch. Um, and in it, the skepticism really plays into thinking of preservation, because all of a sudden someone suggests to you that, well, maybe this is actually dangerous. Well, the danger in these big displays of aurora come with the stress on the power grid from the magnetic material that plays havoc with with anything, power grids and power in general. Now, the thing about this particular outburst is that there was not a major, to my knowledge, we didn't have like any major blackouts happening while this was going on. And then we learned that the Carrington event was actually even bigger than this. It was more of a direct hit, and the scientist Carrington's in drawing, he saw the flares aimed right at Earth. Um, these flares did come to Earth, and they did pelt us. I don't think they were of quite the same intensity. But any of this that I'm doing, um, this was a real cool one too. You like that one, John? Look at that.
Wow.
That was beautiful. And I wanted the shoreline to be devoid of people for this one, because I just wanted to take that.
It looks like a painting almost.
Yeah, and it looked like a painting in real life.
Jeez.
Looking at it, this is what you saw. With the clouds here too.
Yeah,
This is what makes it worth going out at night. I invite everyone to fight their fears and to put aside the need for preservation. Come outside, come see things like this. Drive out, see some light towers, and
jeez, that is
go to your favorite parks. You may not see the Milky Way like this in certain areas. The thunderstorms, take pictures of them. Look at that. From a distance, it's a beautiful thing. Now, if you were right around the area where this struck, you wouldn't be worried so
no.
much about beauty. You'd be upset at the loud noise that was being generated afterwards. But over a lake, that's one of the things I'd always wanted to get. Looking straight up at the sky at Cygnus at the time, and do that with a modified camera, and you start wondering, what's all of this stuff I'm seeing here? And there's the veil. There's a NGC object. There's so much to explore in your own pictures if you take a deep enough picture. Speaking of exploration, once again, it comes down to the people. In this hastily drawn picture, you've got people asking questions, and your learned astronomer telling them about what they're looking at. And I think it's an integral part of what we do. We aren't just about the beautiful pictures, which if you can get beautiful pictures, it's a wonderful thing. I love this one because it's a big, bright meteor. This may be another one, this may be a plane, but that's unmistakably a bright meteor that shot through that image right over C. These are, that's Omega Centauri, my first time seeing it.
You can see it from your
Oh,
Okie
I had
text.
I was in Tombstone, Arizona when I saw
Okay.
Omega Centauri. This is M22. These are more aurora pictures, and I tried to stretch them into panoramas where you could see this SAR, I think it's called, reaching towards the Milky Way over here. This was a Perseid night, and it was upstaged by all of that. Another outburst. It leads to weird things like people saying that there's projectors out there and that there's, that what you're seeing is not true, but
My
you have
buddies
to
got
ignore
shut
all that.
down that night. They went to go viewing at Amboy Crater, and they
Mhm.
were like, I think I'm seeing red. And the next thing you know, the whole sky went red.
Getting lit up. Yep.
And they were
That
happy
was
that they got
October.
skunked because it
Yeah.
was aurora that you've never seen,
Mm-hmm.
So it was perfect.
Yep, absolutely. It's worth seeing and ignoring some of the theories, we'll call them, about why it's there. When folks are not used to seeing these things, or they're told that it's a rare event, you generally don't see it, then some of these conspiracies come out, and you you start hearing of them, and if you're science minded, your first thought is to sort of laugh it off, but the real challenge is when somebody decides they want to come out and see things, they want to see the night sky. Somebody's got to be there to be ready to help them get through it. Now this was at once one chance shot of the comet over here, and this very thin waning crescent moon rising before the sun. I was so happy I got it. This
That
is the
was
full
early
image.
morning, huh? When it was just coming,
Yep, it was when it was an early morning. This was the full image right here, and
and then it rounded the sun. That's
yeah, it
so
did. Yeah,
amazing.
my images of the comet after it rounded the sun weren't as good. This was the final time coming out, and I will I'll end on this one because it's become my favorite background. And this is preservation, Allosaurus footprints. Allosaurus doing its thing millions and millions of years ago, and its path was preserved, petrified. You think you could come here and dig these out, but you really can't. You'd have to try at it, and you'd be defacing a national monument. Basically, it's preserved, but it's not. There's no signage. There's no, um, it's not built up as an attraction like some of the dinosaur tracks are. Further heading towards Clayton, New Mexico, there's dinosaur tracks out there that are built up into a full attraction. These are just sitting there as they were, just out in nature. There's nothing there but you and those dinosaur tracks. And you really have to have a spirit of exploration in order to want to come out here, because there's no human, there's no idea, you have no idea that humans are around in a place where these tracks are.
Where
And
is that?
dark, it's eerie, it's Black Mesa, Oklahoma.
Okay.
And
That's right.
it's beautiful out there. It wasn't fully dark when I chose to take the picture. I just decided I'm taking this picture, and I'm gonna hop into a car that I drove up here, and I'm gonna get out of here. But this was one of the shots I'd always wanted to take when I learned of these tracks. Like, I want to take the dinosaur track image, and this is my latest attempt at it, combining my love of Milky Way photography. There is some sky glow here. That's why you see these colors. And I leave it in. And just the camera's low where you can see some of the footprints going this way of the Allosaurus. There's only a few left. Most of them are covered, buried. They may have even been eroded, but these are what's left of those footprints, those dinosaur tracks. And this is, to me, it's the epitome of wanting to explore things like going to the moon, things like going to Mars, just wanting to see what's out there. And what goes against it, the spirit of preservation, is not wanting to send human beings to Mars at all. Not even sure if should we be spending money on doing this exploration when there's problems we have back on Earth, and um, you know, not believing that it's really time for us as humans to be exploring space. We should take that money and just simply look for near Earth asteroid collisions and make sure we protect this home, this planet. And I grapple with that for a while because I don't see a problem with it in terms of that's not a bad idea to make sure we protect the home that we have. But at the same time, and like you've said a number of times, Scott, the things that we learn through exploration are things that can help us down the road. I mean, there's very important stuff that we learn, and
Oh, yeah.
you know,
I mean, it is the way that we learn.
it's
We're
yeah,
exploring
there's
where,
I just learned I want a pair of binoculars to explore this image you just put up because I could get lost in there.
oh, yeah.
if
It's
you go
so
there,
deep.
just go there and stand there, and hopefully the rest of the creek
I'd like
beds
to
dry.
take a pair of we have this, they're available by special order, but I'd like to have a pair for myself. They're 6-inch ED binoculars. And
You're making 6-inch now?
we can get 6-inch, yeah. And they're very nice. They're very nice. So I'm
My
looking
rock formation images need a little bit of
forward
work
to the day to
when I
see
denoise
some
them.
nice Bortle 1 skies.
Yeah, these are Bortle 1, Bortle 2 skies. So
Yeah.
when you take your images, all you have to do is figure out what's the right combination to show the rock formation in front of it.
Mm-hmm.
And I experimented with a number of different ways to do it, and each and every time I thought to myself, I should have just done some long exposures because that may have worked out a little bit better. But some of my single images, of course, processing those. I'm standing over the edge of a small cliff. If I go this away, I'm gonna fall. I like imaging over things like that the most. Black Mesa is a beautiful place to visit, and I didn't see this mesa when I stopped on the side of the road to take the photo. Once your eyes are used to the bright lights, you don't see anything at all when it's in a place this dark. And so with that, just different images that I've gone and processed over the last few days. And I've still got more for my trip. A lot more to go through. This look at how this cloud
Nice.
covered the Milky Way. There's the comet.
Mm-hmm.
It
What a
was
cool shot.
it's a cool shot. Unfortunately, there's the Milky Way we all
Wow.
know and love, and those clouds sort of did a weird job of masking the Milky Way. They came over, and where they settled in on this image, it was just kind of weird how it worked. And the moon began to rise behind me. And
That's still a beautiful shot. I mean,
yeah,
to get all three, it's amazing.
Well, gentlemen,
Yeah, this-
we're gonna have to.
yeah, we're gonna have to close it down. So I'm gonna stop sharing. And
I appreciate it.
yeah, and
Thank you very much. I was
no problem.
Yep.
Yep,
Thank
I
the
enjoy.
audience for tuning in. We had a nice global audience as well, and if you're watching this in in rerun, you have any questions, feel free to ask us. You can contact our Explore Scientific's customer service department, and we can field questions for you. Or you can wait for the 163rd Global Star Party and save up your questions for that. So anyhow, Adrien, thanks very much. John Schwarz,
for having me.
Good night, guys.
Still there in the background somewhere, but
Yeah.
I wanted to see Adrian's presentation and that last guy, David, was it or no?
Carlos.
Carlos.
Yeah, he
Holy
did a really
cow.
great job.
That was,
Yeah,
I
yeah.
felt like my presentation was remedial after that. It
We
was
had a
so
great lineup today.
Yeah,
So that was
excellent
great.
night. I was very good
Lot of
stuff.
fun. A lot of fun. All right.
Evening.
Thanks very much. And
Cheers.
start
Till
to
we
shut
see you
it
next
down.
time. I'll try to make it.
Yeah, I did it.
Awesome.
Still got
Nanu,
it.
Nanu.
Yep. Live long,
Prosper, my friend.
until Global Star Party 163. Keep
Yeah.
Good
looking
night.
up, even if
Keep
it's
looking out,
cloudy.
guys. Thank you. Thanks.
Hi, I'm Tom Essinger-Heilman. I'm an astrophysicist at NASA's Goddard Space Flight Center and the Observational Cosmology Laboratory. I use sensitive microwave telescopes to try to understand the composition, origins, and history of our universe. This image is our first baby picture of the universe, taken by the Cosmic Background Explorer, or COBE, satellite. Really, I think what's so interesting about this is it gives you an idea of what you would see if you looked out of the sky with microwave eyes. We look out of the sky and we see a bunch of stars. Maybe we see our galaxy. But if you had the ability to look out at microwave wavelengths, this is the sort of image that you would see. See a very uniform sky with these slight bright and dim patches. You'd be looking back to some of the earliest moments in the history of our universe. COBE operated from 1989 to 1993, and COBE revolutionized our understanding of the universe by observing the cosmic microwave background that you're seeing here, the CMB. The CMB is remnant light from just 380,000 years after the Big Bang, when the universe was transitioning from a hot, dense plasma to a cooler, neutral gas of predominantly hydrogen and helium. At this early time, galaxies and stars hadn't formed. What we're seeing in this image of the CMB is the seeds of future galaxies. The red and blue patches in this map of the sky represent more and less dense regions in that early universe, and the more dense regions clump together to form the galaxies that we see in the universe today. This was a first of its kind measurement of tiny fluctuations in the microwave brightness of the sky. The DMR instrument very precisely measured these tiny differences at wavelengths from 3 to 10 millimeters. That's around where your cell phone operates. The CMB is remarkably uniform. These fluctuations are just 1 part in 100,000 of the overall 2.7 Kelvin temperature of the CMB. And they're on very large angular scales and very large physical scales in our universe. Future measurements were able to look at this map of the sky in greater detail and with greater angular resolution. The universe, when this was emitted, was about 1,000 times smaller and about 1,000 times hotter. So when the cosmic microwave background was emitted, this light peaked up in the visible The universe as a whole has been expanding and cooling, and the cosmic microwave background has been cooling along with it. The light has shifted to longer wavelengths into the microwave and closer to the radio part of the spectrum. The idea that you can answer fundamental questions about the history of our universe with a map like this that we're seeing here is just amazing.